All right. Hey, it's this Coffee Compiler Club. Anything to do with compilers and language runtimes and typing systems is all fair game. No set agenda, except that we've postponed Simon for like 4 weeks in a row now or something. So he's going to go first, and you're all being recorded live and you show up on YouTube, within a couple hours. And that's it. All right, Simon, take it away.
All right.
Hey,
Let
you want
me.
sharing here?
Yeah, I'll.
Yeah, try
You
now.
have to allow me. Yes. So, I wanted to give you all a short update on the core language experiment I'm working on, and one of the. I mean, if you're interested, it has now a nicer website with hand highlighted code examples and hopefully some more descriptive things that were removed or changed or added. So if you're
Yeah, I
interested in
see
that,
it.
the website is totally new. Not really, but I hope it's a bit nicer now. Um, and the last few weeks, I've been pretty busy removing things from the language because the goal or my interest is more in doing more with less or doing the same things that we could do 50 years ago, but spending less language
Yeah,
complexity and less language budget on doing it.
yeah,
And one of the things that always annoy me a bit is that people invent special language syntax for procedures or methods with that only have side effects. And that was one of my first actions to just get rid of this extra special case, because in the end, if you're designing the language and you're allowing the special case of leaving off the result type of a function and then declaring it, okay, it returns void or nothing, then you're taking away a lot of interesting options, because not declaring the return result type could also mean it's inferred or it does something else entirely. And
Oh,
so
so wait.
I
So I'm looking at a diff here. There's red code and green code. One has unit and one does not.
exactly.
And you
So
decided to get rid of the unit or to add the unit.
I added the unit. I
Okay.
removed support for methods or procedures, methods without
Well,
return value.
functions without return
And
values, but everyone can do side effects still, I'm assuming.
exactly, yeah.
Okay.
So it's not really prohibiting anything, but I have reclaimed this
Yeah.
syntax on the left side to do maybe something more interesting, like
Okay. Yeah.
having the return type inferred.
Right. I'm
And
always inferring and I always have a return, but it can be nil if you're not excited about the return.
all right.
That's
Yeah,
nice.
I'm always, I think it's interesting to have good compiler warnings about this, and
Yeah.
I think it's a bit dangerous to have not interesting values that you can ignore. I mean, either you shouldn't ignore them or they shouldn't return anything at all, right?
Okay. Yeah.
I think so. Not
Yeah.
sure.
No, I'm working with a little different philosophy, which is fine. I'm just, the simplest little answer for me is everybody returns, no exceptions. And then if you don't care to return something, you can return it to zero or nil, but it's fine. And then you can cast it or not according to what to infer it or not. Like you have colon unit to follow, and I have something similar to say, this is the return. I wouldn't where I put my type, but I'd put it somewhere. Oh, you put it on the name up front. Oh, that's like C code. Oh, that's fine. It's a good place to put it. I always thought C functions were a little weird with the return on the left and the args on the right, but fine.
Yeah. Yeah, you mean the
Int main takes
the
args
algo.
string array.
Yeah, the algo style syntax
Yeah.
versus Pascal style. Yeah.
Yeah.
Yeah, I mean this one is winning, so
All
let's not
right. What else?
with the all stuff. Just
And you use unit instead of void. Fine.
yeah, I mean that the distinction is that unit has theoretically one value, which is not interesting, and that's why you're not really
I thought
allowed to
unit
look
was
at
the
it.
type with no values, or at least that's what Scala pronounced it as.
Yeah, no,
Oh
no.
no, it's
The
unit.
unit is the type with only one value.
Oh,
Nothing
it is
is
one
the type.
value. Okay, fine.
Nothing is the
um,
type without values.
Oh, and there is a nothing. Okay, fine.
yeah.
Now,
Sorry.
just a comment. Wouldn't unit be a bit of an annoying thing to be as a keyword in your system in case someone wants to say have a unit system?
Yeah, that's kind of true.
Is it in the
Mm.
type namespace and not the value namespace? Unit's a type, not a value, not a variable name. I'm asking. I'm not.
Yeah, exactly. So the type is called unit, and its literal is basically is open parenthesis, closing parenthesis.
Yeah, but can I use unit as a class name or as like I'm making just like I like what Derek said. I'm making a units.
Yeah,
type
you
system.
have to import your unit, I guess. I mean, it's just a standard. It's not like void. It's not like a keyword. It's just a standard
Okay,
type
it's
that's
not like a
defined
keyword.
somewhere.
Okay, so I could have a base class unit, and then I have gallons that subclasses from it, and meters that subclasses from it, meters and liters and whatever.
Yeah, exactly.
Okay.
I mean, that's clashing a bit, but yeah, maybe there is some naming workarounds to not call
Well, what does Scala do here?
something.
Scala's got unit floating
So,
around. Do they just give up on it and it's okay? I'm asking Theodore. Here's our Scala
Meaning?
hack.
Meaning the unit, I believe it's defined in the pre-def Scala, but I may be wrong. But
Well,
what
but
do you
can I
mean by
override
unit?
it and just people just don't care to lose the word as a class name?
It's not the word, it's a type. You can prefix it, you can import your own unit, and it
You can
will
import your own
be.
unit. Okay, so it's a
and
standard variable name or type name, and you can just override.
There is a type unit, there is an object unit, the literal, like the singleton value of unit, the singleton
Okay.
class, if you will, of unit, and you can use your own unit, and that's fine.
Okay, fine.
okay, and it seems at least one unit
Yeah.
library in Scala just calls the whole thing unit of measure,
Measure.
which
Yeah,
is, I guess,
Okay.
more precise. Anyway,
It will be shadowed, I believe. If you use it, it will shadow all the Scala names.
Yeah, fine.
Yeah, the end result of this was just that I got rid of another keyword because one arrow down because I
because you
think
require result type for functions.
yeah, it was just it was related. Yeah, I was related. The arrow was related to the result type or return type of function. So
Okay,
in
gotcha.
that move, I also eliminated that. Did the same for lambdas. So there was some.
How do you define a lambda here?
Yeah, it's a bit Rust-like with the bars.
Oh God! Oh, I hate those. Fine.
Yeah, and there were some wild possibilities to define lambdas, for instance. I think this was going a bit too far, and yeah, well, I mean, at least at some place we are now requiring the unit and the return type.
Yeah, I'm
and
still having trouble parsing this.
yeah, I mean, it's like a constant x of type function that takes nothing and returns nothing, or yeah, hey, takes no arguments and returns unit, which is defined as a lambda which takes no arguments and does not return anything, and its implementation is empty. I mean, it makes sense, but I think there are way too many parentheses on one line.
Yeah.
Oh well.
Yeah. Fine.
What is
Yeah,
your
so
or symbol? Is it the word or is it a double vertical?
it's
Shortcut or.
It's a double bar, so there is some slight disambiguation going on
So you could
there.
have a lambda that's double bar X, double bar Y. That would be valid syntax.
Mm, I'd
A
have to
lambda with no
try.
arguments.
I'd have to think about, or I
I
have
guess
to
there's
try to
nothing.
try
I used
parsing it,
Ruby for
but
ages. It had that. I liked it. Whatever. Then I left Ruby and
double
I
bar.
never considered doing anything like that again.
you mean you're trying to do something
So like
like
you've got a. I can't see where you're typing.
in
All I see is a diff.
the search bar. You see it?
I see you typing in the search bar,
Yeah,
upper
Oh,
left
yeah,
you
corner.
see it?
Oh
Top
yeah,
left.
yeah. Okay. So I had my screen zoomed in. Yeah, I see.
So
Um,
So wouldn't it
what
be
are
like
you
in curly double bar X double bar Y, which would mean like lambda, no arguments.
like this?
Yeah,
But isn't the double bar inside the curlies with the lambdas? That's what I saw.
Or yeah, what do you mean? You're doing it like this?
Hmm.
Or
No, here maybe I'll write it in the Google Docs.
all right.
I
yeah.
just have to.
There's like
So
parser ambiguity syntax questions.
yeah,
Why don't we go on
Just
and
have
you
to-
write it and we'll come back to it because I think you have some other short ones in here, like
Exactly.
drop the
Yeah.
percent operator.
Yeah,
Kind of
I
in
basically
misread.
did some research on what languages actually do when you use the modulo operator, and it turns out, as usual, languages can't decide, and the most popular option appears to be the one that makes the least sense from a
Yeah.
math perspective. So
Right. Right.
I removed it completely, used a function name instead, and got
Yeah.
rid of another operator in the language.
I'm kind of in
Which
that zone
is-
too. Like, when do I use the mod operator? Well, typically for hash tables, but anywhere else, it's like
Yeah.
really rare. So I'm all happy to be like, math.mod, and then you can have all different names for the different flavors of mod that you might care about. Negatives
Yeah.
round up, negatives round down, or whatever the hell the options are.
Yeah, or whether the minus in the
Yeah.
result value is determined by the dividend or
Right.
the divisor.
Right. Yeah, maybe there's
And
three.
it's crazy.
Yeah, there's a bunch of them.
I mean, yeah, you have like the one where the sign of the result is determined by the dividend, and I think for this you have basically give me the result truncated, give me the result rounded to positive infinity, and give me the result rounded to negative infinity, and then you have another three with sign determined by the other value and also truncating floor and
All right. Yeah, at some point I'd claim that you can handwrite if you need a bizarre one, and I'd give you the two most popular under function names and walk away from it.
I think Java even recently added all combinations or almost all to the.
That's because Java's been around 25, 30 years, and they're trying to fill out every possible thing. But yeah, I get it. But they went a long time without having bunch. Although
exactly, yeah, I think it's new in 17
and I
or
saw
18.
your other thing. I often will do math algebra with Boolean math, either bit selection or truncation. But for that one, I'd rather have a Boolean math operator that was more explicit about it. Like I saw, things that said like, size mod 8 and equals 0. And that's like every 8th count. Okay, fine, which is fine. But, that one's also like, hey, if the bit for 8 shows up, do something different. And that happens.
Yeah, I'd really love to have something like select bits 24 to 32
do something
or something, and how you shift it around, I don't care. I just want to have a readable way to say, give me out of this 64-bit number the following range of 8 bits or 11 bits or whatever I want. But no such API available, it seems.
Yeah, I've used one when I was trying to do random functions, hash code spreaders in Elm, which all these things had you say bits, dot, and spell out the word and or and shift. And it was really painful. And I needed a way to say, suck in all these operators for doing bit shit. And then, but don't have them in the language normally, because there's like,
wouldn't it
you're either
make
doing
sense?
bit shit or you're not.
It seems like you could do this in virtually any language with a library and using like array slicing and concatenation.
Right. That's at least I think that's a better approach. C guys would hate it, I think, but just saying I want bits from this range or this set of bit. C does this actually. C has a syntax for this. They do bit operators directly.
There is a very nice syntax in system Verilog when you can basically treat bit vectors as arrays, and you can select, for example, bit 34 down to bit 20 when you are in the little endian world, or bit 20 up to bit 34 if you are in the big endian world. It's fantastic syntax. I've never seen it in any software programming language.
Okay, so
the big difference is that Verilog, you're not tied to specific multiples of bits. If you want to have a 3-bit number, go for it.
Yeah, right.
Yeah, and it makes sense. I mean, sometimes the data path is exactly 3 bits wide, so why not?
Yeah.
So they're really good at manipulating those. But in if you're doing this sort of like, imagine slicing and concatenating bits, you need to have some sort of way of saying what the other bits are, which you're stuck with.
Boy, I just hit Google and search, and up pops Verilog bitwise operators. I hardly could type it, and Google already had it. I'm gonna throw it into the.
You want to share it?
Yeah.
I stuck my 10 characters of example at the bottom of Simon's stuff here. So if you want to look at my syntax example.
Oh, is this valid lambda?
It's a very simple question.
Oh.
Right, because
I think like, the lambda is
no argument. X or Y.
No, I think it wouldn't be accepted because the curly braces are required after the lambda after the bars.
Really? Oh, I read that. I thought I read
So
it was
it should be like this. I mean, that would be lambda of x or y. I'm not too happy about the syntax, but I decided to at least not touch it.
Okay. And
yet.
So then what about this one?
Yeah, I have to try it. I have no idea. I think
or a different
B.
function.
Yeah, I think it should
one function or another function.
But I'll save this, write a test for it, and then I
what's your
back.
What's your convention for calling a function? It's got parens after it here. Oop, there's Aaron waiting to get in.
Yes, exactly.
Okay, so I can't make a further confusion. I was headed
by
getting rid of some ors in the middle would clearly cause another different syntax to appear. But you could obfuscated code in any language. But it is good to poke at it.
Yeah, I mean, it's you can give people more tools to write obfuscated code or less.
Yes. Yeah, it's fine.
In Clojure, they just go with the word or. I kind of like that, actually. I think Python does that too.
Oh, or as a
just the word. Same number of characters.
Kind of letters.
And you have to pay one extra character.
Yeah, and
not pay 2 extra characters.
I don't like the not one.
Yeah, not and an exclusive or are the ones that hurt most, I guess. Because at least in my language, I have the basic rule of no abbreviations. So
is XOR an abbreviation?
I'd say so.
Zor. People say Zor.
That's true.
I dislike typing the word not for a bang. Ors and ands I can read, but I'm so used to the C version. And the Zor is rarely used, and I have to think hard about it, and I wouldn't care to replace it with a keyword or a versus the hat operator, like it robs the hat operator. Same as you're yanking the percent. ponder yanking the hat operator.
Yeah, yeah. I thought about getting rid of the head operator when I got rid of the modulo,
Yeah.
but it felt also like either I have to remove all the bitwise operators from none.
No. All right. The philosophy for me is simply, what do people use? What are you trying to accomplish? Kind of thing. Okay, ands and ors show up a lot. Zors do not, but they happen. They're just not so common. And then,
Yeah,
how
that's
much
true.
budget do you want to syntax budget do you want to spend for Zor to be orthogonal versus not?
Yeah, I think it's a hard. You can easily
Right.
go argue both ways. It's a hard.
All right, did you make a
Yeah.
decision on the language literal separator here?
Yeah, I think the more I look at it, the more I'm convinced that I'm keeping this. So for those that missed
Which
it
one? Oh,
last
the
time,
tick. Really?
yeah, exactly.
Oh,
It's
God.
I think it's a real improvement
Oh,
visually.
geez. I can
So-
handle the underscores. Commas get ambiguous on me. But I can't handle
so
the ticks.
I have a question related to this. Are you allowing, so I'm assuming you don't have single quote strings.
I have. Yeah, it's jars.
You do.
Jars is a single quote.
What is jars?
Okay.
A car character.
Oh, car. Yeah. So how do you disambiguate here?
I don't allow the quote as the first piece of a number literal.
So a digit
if
and a
it's-
quote is unambiguously a separator character. Fine. What about the
it's-
okay, so you're not going to get any, like none of the Europeans going to scream about not using the dot. Like there's, the classic American conundrum of dots versus commas and numbers between America and Europe.
I mean, it also depends on the European country because I think
Oh.
there's like one or two where they still flip it around.
Fine.
And it's
Simon just
also
figured he'd
yeah.
piss
It's,
them both off.
Say
sorry.
again, Cameron?
I said Simon figured he'd just piss everyone off.
Yeah,
You're like,
exactly.
"Fine,
Always a
I
good
like
choice.
dots."
You're nobody is getting anything they want. So.
Right.
I would argue the best approach is to allow spaces. It just and then do dots for like decimals mostly because that's what pretty much every language uses. But
allow spaces for me.
yeah,
that would
it
be-
gets really annoying to parse. It's like semi-joking.
Okay, fine.
Dangerous.
Danger. All right. Well, we can agree to disagree on this one.
One thing that's sorry.
I was starting onto a different question when I sort of interrupted
Yeah.
my own question with this, but
Sorry.
I was wondering if this characters that you remove from being special operators or whatnot end up being valid symbols in names. Like, can I have a name that has a hat in it if you got rid of the hat?
So.
And could I
No.
or a name that has a percent in it?
No, I think I pretty
And
much.
if not, why not? I find those things quite useful, to be honest.
I lumped those set of characters into the operator characters, and you can combine any count of those kinds of things and declare it an operator, which is a different calling convention, but it's not allowed in a general name. That was my choice.
Yeah.
So, percent bang percent as an operator or percent hat percent as an operator is fine.
Yeah, because I
were never really
often you end
clear
up
going
with
deep into Unicode.
Say again.
Sorry, I missed that.
You were never clear if we go deep into Unicode, should I be looking at the Unicode database to say, is this punctuation or is this a character letter?
Yeah,
Like when you say punctuation, do you mean this specific set of characters from ASCII, or do you mean anything in the Unicode database that is marked as punctuation can be your operators?
I right now I'm only looking at ASCII and I'm just going to ignore you. Down the road, I need a clear
There's a great,
distinction to parse
there's a
between.
great list someone put together of all the
Yeah,
mathematical symbols from Unicode that
Yeah.
that they used, and it was a recent post I saw a couple weeks ago.
but I need a clear distinction between white space and characters used for symbols and names and labels and operator like characters that the parser needs it. It has nothing to do with typing system. The parser has to have that.
Yeah,
I think
personally, like an example that something I use fairly often is, you have a variable that has a decent name, and then you make something that it's derived, or the next sort of the next version of it, the T+1 version.
Yeah.
So there's a pretty common convention to call it like X prime or whatever.
Yeah.
And so prime is a single tick.
Yeah.
And so I often have like chains of single ticks at the end of my name, but in Clojure, that's a valid name.
Ah, okay.
I mean, not usually more than one or two, but still having X and then X prime and stuff, it's actually quite clear. I like it. I find there is a ability to having some punctuation allowed in your identifiers.
I'll use as trailing digit 0, 1, 2 if I'm working through versions of the same thing.
Yeah.
As opposed to tick, 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 which I get it.
I
haven't
think
sorted out what I'm doing with ticks for me. I have quotes for strings, but ticks aren't currently in my language right now, and I'll probably have to sort on that at some point.
I mean, in my Python code, I use underscore that way.
And that
thing underscore is the derived thing, or thing _2, thing _3, thing _4.
Yeah, I've used underscore as well that way.
Yeah.
I think my guiding principle there is that names should be unambiguously pronounceable. And if you look at like the quote, I mean, I heard already it being called a quote, single quote, tick and prime, and I think I simply don't want to have that in my name.
That's interesting.
And because I allow redefinition of names in the same scope, like Rust, for instance, I feel that also eliminates a lot of the uses where one would use the prime convention, for instance. It would eliminate if you can do let X is something.
Yeah.
And
then that's true. I only fall into that when I'm trying to write SSA for my regular code.
No, but I fall into when I'm doing like simple motion math for gamey things, where I have an X and I have an X prime or a delta X. One is position, one is speed, one is acceleration, and they naturally, from the old school math, fall apart with primes following the name. X prime is the velocity term, all that. And you want them all three at the same time. So it's not a rewrite, it's new variables, really. So there is usually a rewrite option
with that name. Yeah.
I think the being able to redefine the name in the same scope gets rid of all those cases where you don't need the old definition anymore in scope, and you're left with a small subset of the original problem where you need to have both X's in scope. And I mean,
do you allow the types to change?
I think so, yes.
Because what I saw somebody use was thing equals, well, whatever, resource read equals string, some string he got from the database, and then he went through JSON parse it, and thing equals the JSON parse version of the prior string version, and he wanted to use the same name because it's conceptually the same piece of data, but he moved it from string to a JSON to an extractable,
That's a bad idea.
Yeah.
I mean, Rust lives by it. I think everybody writing Rust would get insane if they had to invent new names just because they borrowed something or unboxed something or derefed something. I mean, that's I think this would be very painful. Maybe other languages have it easier there.
I'm not sure, like maybe there's some MLs out there, which I'm not really a big ML user, that don't let you sort of shadow a name once you've made it, but I don't know that I can't think of any language where you can't do that.
But shadow the name in the same scope with a different type.
Well, yeah, so like, in Clojure, you've got immutable names, but I can do a let binding and say let X equals something, and without even closing the let, like without even closing that binding block, I can redefine X to something else.
With another let?
And it's, No, it's like let open square paren, open square bracket, x equals 1, x equals x plus 1.
Okay, that's a reassignment, but
In
how
close
about
square
x equals
bracket.
string? X equals 1, x equals string.
Yeah.
Okay.
Yeah, so you can redefine it as something completely unrelated, anything you like. Yeah, it just kills the previous one, and it doesn't even make it out of its little binding block.
I'm currently of the opinion that accidental redefinition of a different type is a source of errors, and I'm disallowing it sort of arbitrarily.
Not only, but
Mhm.
I'm tempted to say that redefinition of the type of the same variable leads to an unsoundness issues.
It shouldn't lead to unsoundness.
Mm,
It's just as if, for me, all assignments turn into effectively a let, and if you reassign, you get a nested let. So it's a let x equals in kind of syntax, just with standard colon equals syntax.
Mm.
In that case, each new assignment basically makes a new scope, and there's never
oh,
any.
that's fine. That's fine if it's in new scope. Okay.
Yeah, and that's effectively what happens in Clojure. That's what I do in my language as well. It's like I can have this sort of syntactic sugar where you can define a bunch of things in one let statement, but it immediately gets split up into a bunch of single binding lets. But they all have the same sort of scope boundary, even though they're nested. So, right, it's like each one is defined one step inside the other, but they all end at the same place.
But you've stacked all their closes and maybe made an efficient representation of stacked closes.
Yeah,
it's fine.
There's no statements between those anyway.
Right, that's what I meant by stacked. They're one on top of each other. The closes are. Yeah, fine. All right, we move on here.
Exactly. I was the next step. What I was working on was name bike shedding as usual, and I extended option and result, and I think it's most of it is as expected. But one thing I'm really happy about is the replacement of the thing that is usually called filter and filter not. And for me, the problem is that I can never remember whether filter retains the elements for which a predicate is true or rejects them. And I came up with retain and reject, which both starts with the same letters. They are both exactly the same size, and I think it looks pretty. I'm really happy with retain and reject, and yeah, let's see. I think it's one of those combinations that work really well together, and yeah, here you see some lambdas with types in action for those that were confused about the syntax previously, because I think the short example with only parentheses and brackets and curlies were not helpful. Yeah. So really happy about that.
Oh, there's all kind of stuff going on in the chat too. Most of it's a quick read. We have to look at Aboriginal generics.
Yeah, the Go thing. Yeah, exactly. I think this was very famous. Some Go code generation library used these Aboriginal symbols as a replacement for generics. And
okay, fine.
there was a lot of madness involved.
Well, there's the comments about, hey, currency characters for use in variables, which are legal in Java. I know you can have $sign. I didn't know you could have all the remaining concurrency characters on the planet. So like, the Zelda game has rupees or whatever, rupees. Is that a legit?
I mean, if it's in Unicode and if it's in the correct character class, I think you can use it. I think pound and euro works. So that means
can you use other Unicode number representations as numbers? Can I do my numbers as Unicode
I
rolling
don't.
number?
I don't think so. I'm not even sure how it's parsed. I think it's. I'm not even sure. I guess it depends on how lenient Rust underneath works. But
Yeah, I'm not currently going to parse any numbers other than, 0 through 9 and do a number thing with them, right? If you had weird things and you threw them as part of an identifier, X, whatever, alpha, that just kind of flows through. That's not a problem.
Why did you
All right.
decide not to have a separator between the number and this is an I32?
let me check where.
What are you talking about here?
In the number syntax where you were
Yeah.
using the ticks,
Yes.
you had like 1 tick 000 I32.
Oh, I didn't miss this one.
Here. Yeah, it
Oh, okay.
feels. I'm also not so happy. I see the readability concerns there.
Yeah.
I'm not sure.
I just think I's look like ones.
Yeah.
Yeah, I mean, would it help if we would require a quotes there?
Well, do you have a requirement
Something
for,
like this, read better?
are you,
Because I think the space one is really
wait,
opened up all the issues as before.
back up a second. How many I choices are you allowing? Like Java and C say there are 2 on the numbers, there's ints and longs, and you put an L or not, and that's your 2. As soon as you assign it, it can truncate it down to the size you assign the variable based on the type of the variable, but the actual number is always parsed as either an int or a long. There's only a choice of 2, and so you only need to have something to distinguish between 2 things. And I'm asking, are you expecting somebody to write a constant number and want it to be an 8 instead of a 64?
I think currently only 32 and 64 are
So if you only have
required,
32 and
but
64, why don't you choose a different syntax that's distinguishing 2 different things, where the canonical one is the trailing L or not?
I think it's useful to have the literal syntax reflects the types. So I don't have int and long. I have int 32 and int 64.
Yeah.
And that's like, I mean,
Yeah.
one could also write it like this, maybe. I'm not sure. I absolutely see the issue there, but I haven't found a good
Okay.
solution
Yeah, I
yet.
claim if you have just 2, you're good. And actually, C++, C went to the quad word for 128 bits with double L's. And then beyond that is like less useful in that syntax. And also people don't write them. And also you're going to have a big integer anyhow.
Yeah, I mean, the only reason why you see the I32 is because I64 is default. So float and integer have both the 64-bit representation as a default.
Can you silently assign a 64-bit constant to an int32 number?
No,
You have to have a syntax.
No, I have no implicit conversions of any kind.
Yeah, okay, fine.
Do you have an opinion on big int literals?
Not really. I mean, there are various ways to implement this, and they all have varying costs of supporting them in the language versus adding some library that, of course, then looks different than the native literal syntax. But yeah, I'm not really.
Yeah, I kind of like JavaScript.
Really
I just stick an N on it, and now I can have arbitrary precision integers. But yeah, that's both good and bad.
Yeah, fine.
Yeah,
I
I
mean,
briefly experimented having just also by language only has 64 bits integers. That kind of simplifies it. But I did experiment briefly with separating signed and unsigned integers. My setup there was that signed was the default, and for unsigned you stick a U at the end of the number. I ended up scrapping that because there's very few cases where you generally need unsigned integers, and you can't just cast to assign integers back and forth if you have 2's complement. It gets a bit annoying with some cryptography because you'll look up the implementation and they use unsigned integers in like some table.
Yeah.
And you have to figure out, okay, what is the signed representation of that?
And did it wrap or not wrap?
Yeah, you get these annoying things where what I would do is I would take the number, I would stick it in a Ruby REPL, convert it. I would then like sort of wrap it and then convert it back to hex. But then you get these issues where some languages are inconsistent in their dealing with negative hexadecimal and binary numbers.
Really?
Yeah, so in Ruby, if you do like, minus 0xf and you cast it to a string, for example, you get minus 0xf. In Rust, you get 0xf because it doesn't treat the minus as part of the number. And this was a case where I ran into later with like negative hexadecimal binary numbers. The Rust number parser that they have doesn't support it. Or specifically, it supports, if I remember correctly, if you do minus f and say this is hex, it'll be like, great. But then if you do minus 0xf, that it doesn't support. So then you have to like strip off things. And so because of that and a bunch of other issues, like, you know what, I'm just going to have one number representation. No differences between 32 bits, 64, 8 bits, whatever.
Yeah. I feel that's the way most C stuff works, where like all the structs and a lot of stuff is dependent on the operating system or on the CPU architecture is way overblown. I mean, in these days, I think it's more helpful to have a defined standard definition of, for instance, a defined memory layout of a struct, and not saying, all right, okay, I'm compiling for 32-bit platforms. I am now saving 4 bytes at this position because I'm using a platform integer, and the platform integer is now 4 bytes, and this means the whole struct now looks completely different. I think there is just not that much value anymore doing that.
If you're in the embedded side,
yeah.
I think that depends on what language
and...
you're building. Like if you're building a systems language and embedded is one of your targets, or like you really care about the extra few bits, then it is useful.
I mean, for the language I'm working on is garbage collected, so I'm safe from all the embedded stuff.
Okay, fine. So if you're working on the microprocessor in your headset, you care.
Yeah, I mean, use Rust. Who cares?
Yeah, but those people often would be fine using an int 8 or an int 16. They don't necessarily need the word int or long.
Yeah, that's
different because they're on a different platform.
And in fact, I'm totally on board with that one, because the weirdness about the int platform specific thing is the performance gained by flipping one to the other is not nearly worth, in my opinion, even on embedded, it's not worth the semantic overhead. I need to know how many bits I have to know that I'm not wrapping or not, because I care on these embedded guys. Like int64 just doesn't wrap unless I'm being stupid, but int8 wraps all the time. So, but I care between int8 and int16 if I have a tiny chip doing tiny things.
Yeah.
So I have to understand the number, and so I want a fixed number, not an architecture flip-floppy number.
Yeah.
I
think the language should give you int8 and int16, and if you need a piece of code that is generic in the sense that there's both an int8 version and an int16 version, you write your macro.
Yeah, exactly.
We don't need to impose that on every other developer in the world because of that use case.
Yeah, I think the human effort to get these platform integers correct would be better spent on having the same amount of development hours, just optimizing code in general. I think that would be the better result.
All right, let's move on here.
What about the other side? The uint 128 and uint 256 that there aren't registers for, but it might be convenient to give people 256-bit numbers because people like to do math on keys.
Yeah, those in my head fall in the category of cheap enough to, language syntax wise, really cheap, and implementation is a call to some library that handles power 2 sized, big integers.
Mm.
So
Yeah.
you throw it in if you want to deal with it.
Yeah, I totally agree on that. I mean, we are now like we have I512,
Hmm.
I guess, but I don't expect it to get that much larger, excuse me. So
Oh, I imagine some
I-
crypto guy will promptly turn around and say, "No, I want 1024."
yeah, I mean, no, I don't think any CPU manufacturer will ship a CPU with
No.
I4096 wide registers.
They'll just
or
do a
something.
SIMD
So
thing at you, and you'll.
I
have
think
it.
with this case, I'm fine with the limited extensibility I have.
Yeah.
I have like the I prefix, and I use it for numbers. And I think I see the big int problem actually I think it's a bit a bigger one, because I probably need to pick some other letter for big integers, and then the question is, okay, if we're now picking all the letters of the alphabet, what do we do when we run out? And I think that's the question I don't really want to deal with.
I think you're a long ways from running out yet.
Yeah, true. But I mean, if you start assigning individual letters to magic stuff like big int, then the next person comes around and says, okay, I want to have rational. Then the R is gone. Then the next person says, okay, I want to have complex. Then the C is gone. Then the next person says, okay, what about quaternions? Then the Q is done, and the alphabet gets quite small after
All right.
a while.
Stop.
But anyway, right, yeah.
That leads
So,
to one of my favorite Python quizzers.
Oh.
If you are in Python and you type
Oh,
020 plus 020j,
Oh, gee.
what number do you get back?
Well, write it in the docs along with the answer, and I'll shoot
probably
it there.
the first one is a complex number supposed to be both.
Right. So
numbers
020, the leading zero tells you it's an octal, so you get 16. So 020
second?
plus 020j is 16 plus 20i.
Because the second one is not interpreted
Right.
as
When you add the
octal.
j at the end, it goes, oh, this is an octal number.
Octal.
Octal numbers
Alright.
can't
Octal
end
is
with j, so that one's decimal.
That's bad. That's
Octal,
bad.
Octal is about the worst idea ever.
Yeah.
It was a perfectly fabulous idea in the 60s.
So
Apparently
Well,
they've
just
changed
tried
this,
it.
because I just fired up Python 3.
Yes, Python 2. Python 3
And-
fixes this.
Oh, okay.
Nice.
Yeah, you need 0 now.
Stop me before I get hurt.
but I also think that if you're forcing the developer to suffix their numbers to get them to not get hammered, there's something weird.
Well, that's an argument that says no number suffixes, which I could kind of agree with. There's a theory that says for ints and longs, I can tell by the size of the constant, and then you're going to assign it to a variable, and that's going to get free casted, not for assignment for me. For free casting.
The F and the D stuff in Java, for example, is just
right. But if you drop the F and the D and you just declare them all a D, and then it assigns them to a float, you just round it. I guess that one is a little harder to do. No, it's not. You just complain if it doesn't fit in a float.
I mean, if you
You have an opinion on fake functions that if I say I60, I32, open parentheses, give you a literal number, close parentheses.
Yeah, there's
that's not a real function. That's actually a reader macro. So it knows never to like make the thing and then cast the thing.
Yeah, there's a function that I think applies when you go to big num for sure, and probably for complex, I claim. Just go to a function that does a constructor call.
yeah, and you know, I can't tell you how many times I've cursed at Java trying to get it to accept numbers for bytes and whatnot, because it's like, oh no, you've got to explicitly cast that, or what, you know, it's all the.
Yeah. Once it gets beyond some certain point, it requires casts.
Yeah, I mean, byte assigned. I mean,
Yes.
everything above 127 is a problem.
Well, the fact
Yeah.
that Java has signed bytes is idiotic, but
Yeah.
Signed
I mean,
bytes. Oh, signed
signed-
bytes.
signed
Yeah,
bytes, like,
signed bytes was
what a
idiotic.
fucking
Yeah.
stupid idea.
Yeah.
I mean,
I-
it's
I-
like
I
they
love so much about Java that the warts stick out like flaming disasters.
Yes.
know.
Right.
But
Yeah,
that's one of
unsigned ints
them.
are nice.
Well,
if you're
no,
writing
no,
a language
unsigned-
today,
Well,
it's nice
no,
to have
no,
unsigned
a
ints
byte.
also.
A byte is an octet. It's bits. That's what it is, right?
Yes.
There's nothing signed about it.
Yes.
It's
a
an enum with 256 values, if you will. It's a
wad of bits. Yes.
it's a wad of bits.
No, no signing going on here. And I do all these parsers for languages. I pull up bytes out of the network buffer. They're bytes. They're not characters. They're not Unicode. They're bytes.
Yeah, and by the way, that signed byte stuff has actually been the source of some major outages in
Oh, really?
software over the years. Oh yes, I've debugged a few of them over the years.
Who's grabbed a byte and had it be wrapped? I mean, I failed my parsers occasionally for this shit, but never anything like systemy. I went straight to ints
Well,
as fast as I could.
Especially because of the implicit 8 to 32-bit expansion of byte in Java.
Yes. Yeah, if you
So-
grab a byte and you do an array lookup as an index into an array, and
Oh,
the
that would be
byte got
bad.
big, you throw a negative array size. Like if you have a character array, yeah, okay, fine. If you have a character, I have a translation table of 256. I load my byte and I look up in the translation table. You failed. Suck. That's true. I didn't think about that. Fine. All right.
Yeah, I have one interesting bit about having first-class type classes. I didn't implement this. This was the guy that worked on this before, and it's cool that it just works. So if you, for instance, want to flatten an option of an option or a list, most languages don't really give you an easy way, especially not if it's not supposed to be a static utility method somewhere, but supposed to live on the instance itself. So they can say a list of lists dot flatten and get back a list, for instance. And even in Scala, where that allows you a lot, you have this infamous syntax where you have like the implicit evidence of A being a fallen Christmas tree of option of B, and in core it's
I have my stock answer for that, and that is if you're using lists, you should be shot in the first place. Don't be using lists. Smack, smack, smack. Now flatten problem goes away. No flatten if you got no lists.
I think
Why
he
don't you like
speak
lists? You use
more.
arrays all the time.
Absolutely. Array list versus linked list is like
yeah,
2.5 to 5
linked
times
list.
faster and 2.5 to 5 times less memory, and
Yeah.
has almost perfectly the same API. But it supports these kind of things in a much more reasonable way. Fine.
But I think Simon
it's
refers to nested types in itself.
Yeah, I don't ever see array lists of array lists that I want to then flatten as a programming paradigm that I ever fall into. I've seen many people talk about it. I see all the support and libraries for functional programmers. I never ran into it, even when I was doing hardcore functional programming. I don't understand where that came from. So don't try to explain it to me. It's just my personal coding experiences.
Yeah, no,
I've never
it's
called
fine.
flatten in my life. I never had a use case where I would want to call flatten. So I don't care.
Yeah,
Option
yeah.
upon
The
option.
point the point the thing I'm trying to express is more or less not like you can implement it, but it actually looks nice in this language because I can explicitly say, hey, I have a method implementation that only works for option of T, and I don't need to do the Scala workarounds with the
But
implicit evidence.
I'm tempted to the implicit evidence here is the evidence that A is an option of a B, but in your
Is a
point,
subtype of an option of a B.
Yeah, it will for all intents and purposes it will make an A an option of a B in order to figure out that the current A is an option of some other type. But in your example of unflatten, if self is some val, that requires a runtime check.
In
Here.
what sense?
Yeah. You got a
This
one-time
is-
check
this
if you want.
This would happen at runtime, the flatten, and I'm tempted to say that
I mean that no, in the Scala case, the check also happens at runtime.
Right.
It's what I like is that this signature here, the option of T, is more explicit than the implicit evidence A of fallen Christmas tree of option of B.
Okay,
And that's all. I'm not.
Yeah, that
I
would
think-
require the rest root of the implementation of the impl construct instead of.
Are all of your nuns typed?
I saw that too.
I think it's required at this point. I'm trying to.
Okay, so you have no such
Fix
thing as a
it.
naked nun. Every nun is that there is a specific thing that a nun is not.
Exactly. I mean, it's just a class without any arguments. No, I think it's an enum variant without parameters. And because we also don't have type inference yet, I get to write this T everywhere, and I'll try implementing type inference in the coming weeks, and then I'll reevaluate whether this is still a problem or not with type inference added.
And I
Yeah.
will have to check if the implicit happens at runtime. I'm tempted to say that isn't the case because
I mean-
if you use this and the Scala compiler cannot find an implicit evidence that the
But
A
that's
is an
not
option.
the point. That's not the point.
Oh.
Deciding whether it type checks is done at compile time in both languages.
Mhm.
But I mean, this where you said that's a runtime check here,
Yeah.
deciding, okay, is the thing I have a sum or none?
Yeah.
That's also happening at
Yeah.
runtime in Scala.
Mhm.
It has to be. No, I hand you two random lists. I hand you a random list that contains a random count of other lists. How is the type system going to turn this runtime value into a complete flat list? He has to run some code. He has to go ask the question, are you a sum or a none for the top level guy? And if it's a sum, then he can, take the second list and deal something with it.
Okay.
I think my tip here for Simon is if you're gonna write type inference for this, based on my personal experience, this is like a really big slippery slope.
Yeah,
'Cause-
yeah, absolutely.
So because you have the simple
Says the guys that
case,
spent the last two years on type inference.
right? Because you have the simple case where you do let x is none, right? And then the compiler's like, obviously there's no type, so go away. And then you do let x, a colon int is a colon option int is none, whatever your type signature syntax is. And then we'll figure out. Okay? In that case, you can handle you handle your let. You say, oh, we have an explicit type, so blah blah blah. Things get really annoying if you don't have that. So if you have like if something, give back a sum of the number 42, else give back a none. For cases like that case you could still special case, but very quickly you'll run into cases where you essentially bidirectional type inference.
And then you have to pull up some variation of Hindley-Milner.
Yeah, and I don't have Hindley-Milner. I have some sort of bastardized version of it somewhere in between, because I don't have what is Hindley-Milner called it again? The variables where it's not like a type but a set of rules of what the end type has to conform to. I forgot what they called it. Different people call it different things. So I do have like only nominal types in that sense.
Ground.
But I do have a
duck typing
placeholder
versus structural typing.
No, so in Hindley-Milner, because its types are more like rules, as in there's not an exact type, it just has to have this function or
it has to have this property of a shape.
Right.
Yeah.
And so in my type system, they are exact. So it's not like, oh, this is something that must have this function. It's like, no, it has to be this exact type.
So you don't bottom out at leaf terms, you bottom out at ground terms.
Also, I do have placeholders. Those I stole from Hindley-Milner, and that's where a lot of the trouble comes because
Well, that's where Henry Moner does his shit.
Right, but so you end up with these circular problems, and you try to print the type, and it crashes because it's circular. So
Yeah, right. I spent a
in
lot of
my
work making mine handle circular types. So that's an occurs check, sir. If you take the
Right.
occurs check and you put it in, you'll simply blow up and say, "This is a self-referential language construct. I ignore you. I spit upon thee." Right.
Right.
Or you do
But
all
so
the
that's
hard work to do
my
circular printing.
tip
and
there. If you
circular everything.
gotta, if you want this sort of type invariance, at least based on my opinion, yeah, immediately toss in a check saying if we recurse more than 100 times, screw you.
Okay,
Because I
that's a
tried
different
way
check.
too long trying to
Yep.
cover all these cases. Like, oh, if we have a type parameter that's assigned to a placeholder that's assigned to the same type parameter, then we do this, and eventually like, no, this doesn't work. Here,
Not to
check
mention-
if you hit the depth of 200, screw you.
So
Not
I
to
did-
mention all the
yeah.
unsoundness involved, usually in allowing some kind of recursion.
So I
As
started
Ian
with
Shallop
having a
found
count,
out.
just like you said, and I threw up when you got too big. And all my cycle finding loops have that count under the theory that you didn't write a 200 element cycle type, just in case I was buggy and off in the weeds. But I eventually got the cycle thing working.
Recursive types are pretty nice, Simon, so I'm not sure what you were after there.
Yeah, of course they're nice, but they are a huge cost.
You can do Henley Milner with the occurs check, so no recursive types, pretty straightforwardly, straight from the the wiki page or the articles on it. Like the base Henley Milner is not too bad.
Yeah, it depends. If a language has variants, the rejecting recursive types usually has a huge price, because
I'm saying if you don't have recursive function types, so recursive types or structs are fine because you name the struct up front, and then you don't have you don't have the problem of discovery of recursive types. If you don't have recursive functions, that's what the occurs check cuts you out. I claim you can go straight down the Henley Milner for this kind of stuff. If you want to do the recursion piece, then yeah, you got some more work to do. I burned some time doing that, but once I sorted out what I was doing, it all came together in another couple of weeks worth of work. I mean, my other extensions cost me a lot more than the cycles, but I had to deal with cycles, either say no ever, or I dealt with them eventually. It can be done. Have you ever worked with cycle finding algorithms? Like any stock compiler doing an optimizer has a cycle finding algorithm in it. If you've not worked with them, it's annoying. Okay, fine.
Yeah, I've only seen the efforts in Scala a long time ago.
Okay, fine. That's a target strongly connected
avoid.
components. Look up the SEC strongly connected components algorithm. I coupled mine with Henley Milner straight up, but I'm pretty good at both of those algorithms.
All right, thanks.
Yeah,
those algorithms have weird complexity. They're like n in the worst case, but essentially never worse than logarithmic.
Well, that's the union find piece. The cycle finders are in log in theory, but yeah, they're usually in. Like you have to try hard. Like one pass, you got it. Actually, I think the straight up normal cycle finder, if you use the really cycle finder on a true graph, it's just linear. In fact, it's cheap ass linear. Like the amount of code I have for the cycle finders that are directly just doing cycle finding and not other support things around them, that's like 10 lines of code. It's like really stupid. But like my pretty printer and everything that walks a type, so all the unification in Henley Milner all does cycle things. So they all have I hit the cycle part check. So they all start out by saying, I make an empty mapping table that maps, I've been here or not. It's a bit set or a hash set or whatever. And every algorithm's first step says, if I'm in this looping table, then do a magic thing that's the cycle, else do everything else, and then put the stupid thing in the cycle table. And then, count, make sure I don't hit the infinite list. And when you're between these algorithms, clear out the table so you don't have to stare at it afterwards, or you don't pick up bits on the next go around that are incorrect, and a bunch of engineering crap goes on. But there's a cycle finder in every possible algorithm now, unfortunately, or a cycle dealing. But the finder itself is, like I said, it's tiny. But dealing with it everywhere is trouble. Type check, match, ref, mute, infer. Whose is this?
This is your code example
Oh,
of
yeah,
how
Inco.
the
Yeah.
of how it deals with it in Inco.
Yeah, I just realized the link is not jumping to the right line. So 1 sec, let me
Oh.
fix that.
Which line do I have to go?
I just added it because I made a permalink later and then it permanently messed it up.
Yeah.
But it's line 3951. So that's where I have like a def check where I just say, oh, and I think the def I have like 64, whatever it was, and
Yeah,
it just
yeah.
bails out.
Just give up. Oh, you actually quit. I threw an error saying I should have found this cycle a long time ago. I must have a bug in my cycle finder.
Yeah, so right now my system's kind of stupid. Similar with type checking, if you have like a deeply nested type and somewhere in the depths of it, it fills a check. It just says the check field.
Yes.
It doesn't say, oh, it's because this subcomponent.
No,
that's
I
something I'm
throw an
going to do
assert.
later.
I don't return anything. I assert in the debugger. Boom, you're dead. Go to the debugger, fix your bug.
Well, also in this case, the unknown type gets called later on because later on this.
I see it, Dan. Yeah.
There's a pass where it essentially goes through the types and make sure they are valid. And if at some point it gives back an unknown, it's like, this type can't be inferred. Fix your code.
Yeah. Okay.
I think this was also a core lesson of Scala some time ago, that having that's failing inference, assigning nothing like the real nothing defined in code it can be a problem. So they didn't have I think, I'm not sure how long in every case, but there were cases where failing type inference was not, you couldn't really see that the compiler was unsuccessful because it just returned nothing, like the bottom type, out of some computations. I'm not even sure if and whether they fixed it, but I think there was some instance of this where it would have been really useful to have some kind of type in the compiler that said, well, inference failed here. And
I have an error type, which is basically a union type. You're trying to infer that a string and an int are the same thing. So I'll let you with this error type, and the error will be both an int and a string for right now. And all your int-like things will do the int, and all the string-like things will do string things. And when we're done, I'll say, and also, you've got an error type.
all right.
Yeah, I do have a error type for similar reasons. I think technically this function could return the error type. It's just I have an unknown type because there's a few places where essentially I have a field somewhere and it needs to store a type, but it's not initially known, and I didn't want to wrap it in an additional option. So I just have an unknown type as sort of the default placeholder.
As opposed to a leaf in Hindley-Milner or a placeholder.
No, so opposed to having like an option type wrapping a type, and then every time you have to use it, you have to like explicitly unwrap it.
Scala does the same thing. It poses a question mark for the type. It knows it has a type, but it doesn't figure it yet. So it puts a question mark.
Yeah, I don't think I have to do that.
No.
I need to see an example where
the Hindley-Milner resolve the type after the fact, but Scala doesn't. Scala is a local type inference, so it needs to work with the type. The Hindley-Milner can resolve what the type should be after the fact, after it's figured out what the
when the unification's complete.
Yeah,
that's when the algorithm's done.
And that's when you know it can it be a type or it's a type error.
Oh, okay. So for me, if it moves from a type to a type error is a type.
Mm-hmm.
That's just generously allowing all things to unify with it. So it allows all unifications to proceed correctly and carry on.
Yeah, but for Scala, it needs something, so it puts a question mark type.
Well, but you need something in the sense that he'll figure it out later, or he knows he's already got a problem and he doesn't know what to do with it.
Figure out later.
Figure out later. Because for me, Hindley-Milner, when he's done, he's got it all figured out. And in the middle, he's got leafs, or what I call leafs, we might call placeholder. He's got a type var that's not yet
resolved.
And that's the normal. In fact, everyone starts as a type variable that's not yet resolved. They're all leafs. And then you unify the hell out of things, and it all settles down until you get, your types are done or you get errors. So I end up with, I start with everything's a leaf, everything's an unknown type or a blank type variable. And you gradually remove them. All right.
So,
All right, shall
Simon,
we go on?
Yeah,
Okay,
sure.
let me show you something where I'm really unsure whether I need to have some way of
Oh, your equals versus
detecting
equals.
and warning about it. So where is it?
You added equals and hash and stringable for option.
Yeah, I'm just trying to see where I give me a second. Maybe this one is better. Yes. So basically I had types where I where I implemented methods like equals and hash code and toString. Is there any useful thing I can use which is on the same line? No. Let's take this equals one. So I basically implement a method that's called equals, but I forgot to tell the language, actually, I'm implementing this equals trait, which means if I wrote simple code that used result directly, I was able to use equals for it. But if I had a generic type or some kind of interface or anything, this code wouldn't compile because it said, oh, well, this result, for instance, is not implementing the equals trait. And I made this error for equals. I made this error for toString, where I had to add this stringable for. And I also, I think, made this error for hash somewhere. And I'm really unsure if there's a good way to prevent such errors, except having totally different syntax for like methods that are just defined on a type versus methods that are supposed to implement an interface.
So I think this is a problem you'll have in a fairly, I think basically every language out there not made in like the last 10 years, where you have a couple of methods like equals, toString, hash, that they're implemented such that the arguments those methods take are the top bottom type one with the like object, right? So I think in Java you have this. In Ruby it's similar. I mean, Ruby's dynamically typed, but you implement, for example, equals using a runtime check because you don't really know what the exact type is. I had some similar issues with my language where very early on it sort of did. It didn't do that. It just assumed that you passed the right type. But so I have a similar approach to you where my types don't provide an equals method or hash or toString, whatever by default. You have to explicitly implement the traits that provide them. In my case, the syntax is a little different, but it's the same idea. You say like, implement toString for array if its type parameter also implements toString. It does complicate your type checking a little bit, because what you end up with is you have, let's say, an array of floats, and your float type does not implement equals. What you end up doing is part of a type check is you say, okay, give me the equals implementation for the array type. That one it will have because it's sort of implemented generically. But then you have to say, oh, wait a minute. It has this extra constraint which says we are only available if array's type parameter also implements equals. And so you get a slightly more complicated type check. And that gets further complicated with type inference and things like that.
Yeah.
But I think you only have essentially, well, 3 options. One, runtime check, but you basically get the worst of everything. Separate functions. So you don't have an equals method on your array type. You have a array equals something function.
Yeah.
Or you do this approach where you essentially have traits implemented conditionally.
I also think this one is the cleanest, but I just found it dangerous that I was able to write this, and when looking at it, it basically worked.
Yeah, I think here the syntax definitely is
And-
ambiguous in that sense. I think in my case, so the syntax for implementing traits is somewhat similar. Like it's impl trait name, optionally with type arguments for and then the type. In my case, what I ended up doing is when you either reopen a type, which in this case is only possible for classes, or you implement a trait for a type, you can discard the type parameters of the class. So in your example, where it says full result flat brackets TE, those flat brackets you could just leave out. And then
but are the do the names here still have to match the names used in the class, or is it positional?
Let me quickly dig up an example that's probably a little more clear. One second, where's my files? Oh, there we go. Because I'll just pick an example for the array type. That's probably the easiest to understand. ToString equal. I don't even implement it. Oh, here.
You have a link or the Google
Yes,
Docs?
1 second. I'll dump it in the chat.
Oh, I saw it. I'll open it.
So in my case, this example, I still made the mistake that my equal interface or trait, it defaults to using the self type as its argument instead of the trait being generic.
Yeah, I have the
and then you run into soundness issues later on, where if you cast things, so ignore that part. But the syntax here essentially, the constraint is the if t also implements equal part. And then if you end up, having an array of floats and float doesn't implement equal, the compiler will say like, hey, the array type does implement the equal trait, but it's not available because blah, blah, blah. There is one edge case, which is in my language, you cannot implement traits for traits, which in Rust you can do. You can say like, oh, if a type implements this trait, it also implements that trait. So I do have this weird case where I wanted to have a method that takes an iterator and joins its values together by some string. Because I cannot implement traits if another trait is implemented, I had to make that a standalone function. So there's a function called join, which takes some iterator that implements the appropriate stuff and a string. And that's a little odd.
I have the same issue with the exact same type.
Yeah.
It's funny.
And that's when I ran into that was almost a point where it's like, should I just make this a functional language? Just be done with methods. But then I kind of was like, you know what? It's actually not that big of a deal to just have a join function that you import. But yeah. The alternative is you do the Rust system where you get this really complex type system. You say, oh, if you implement this trait, you automatically also get those. And yeah, I didn't want to go there.
Yeah, it makes the things a lot more complicated. I think, yeah, you see down here I have a trait iterator, which is a special case to one specific range in 32 iterator that uses it because I can't even, because everything is basically based on a self type and I can't even use a type parameter here. And I need to fix this, but nice to see that here sometimes
I would like to claim
same types give the same problem.
I would like to claim that Henley Milner can work through this one directly. Because, well, what I'm doing with it is just extending with structs, which is very easy extension over Henley Milner, and then the equals operator is a struct member, and if you have an array with an element type that has an equals, then the equals and your array equals will pass the type check, and in the context where he doesn't, he'll fail. So if you call array equals on something that doesn't have an equals operator, you'll get a type error from Hindley Milner sort of directly, or not according to whatever. I think that one I think comes out. But having said that, I don't have it in my face to verify, but I think it's true.
Yeah, I think Hindley Milner wouldn't have any issues with this. I think it's just a limitation that happens if you implement a language where you're not planning on having type inference as a basic first step, and then you basically write traits where self is handled in a special way, and that gets you quite far with traits, and then later on you realize, okay, I have all this slightly more complicated traits that really needs to have type parameters themselves. And that's all.
I happily went down the path of no Hindley Milner for a good year before I decided I absolutely had to have it. And I got really far into a lot of things, and there was some cool shit I just couldn't do without it. And Hindley Milner. Fine.
So Yorick, what's the with doing here? Is it just another?
Oh, that's just the argument. So with is the argument name.
All right. Okay.
It follows the same Rust syntax.
It's just like the separator.
Yeah. So in this case, the flat brackets, those are the type arguments. Either and with are the argument
okay.
names.
I thought this was some kind of shorthand to constrain.
No, it's just
further or
it's
something.
because I do have named arguments, and so I've been trying to use these natural sounding names.
Makes sense. Yeah.
Interesting.
All right. I think I'm almost at the end. So let me just try to get through this. And as I mentioned a few times already over the last weeks, I guess, is that one of the basic rules of me designing a standard library is that it has to be a word. And I really hate abbreviations because everybody abbreviates things differently, and oftentimes people also pronounce abbreviations differently, and just using words is sometimes I mean, come on, it's just use words. And that I applied this to vec, which is array list, and just called it list. So one fewer magic abbreviation there, and
okay.
Nothing to. I think it's made the language a bit nicer, even if list is 4 characters and set and map are 3 characters, so things are not lining up. But yeah, I think code where you're using a map, a set, and a list at the same time might not be the standard use case for this.
But you still use enum and fun.
Sorry?
You still use enum and fun.
That's true. Yeah, but I have a list of like categorizing things. I have like big shapes, little shapes, control shapes, and try to have all of them as a specific word length assigned. I'm not sure I'm finding the article, but I mean I have worked this out in great detail, how many letters each category of keyword should have. So time I will never get back.
All right.
Another thing I'm currently working on, I can't really, maybe I can show it, but it's not interesting because it's not working. I'm trying to implement semicolon inference so that I can leave out semicolons as terminators and use line endings instead. And
I did this for an R parser I did a long time ago, and I claim it was a pain in the neck and probably not.
Absolutely, it's like if you get it to work, it's fine, and you probably don't want to touch it. But the process of getting it to work is really painful because you're moving
Oh,
things around, and even slight changes break
yes, yes, the parser
break
became
things that
fragile.
break things that were working previously. But I can recommend this resource on Semicolon
Put a
Inference.
link in.
I
And the
think
other thing I would say was that the R code I read that had the semicolon inferencing on it was not terribly more or less readable with or without the semicolon. So I just said I'm not gonna. I chose not to do it in AA.
I'm
So
always,
when-
I'm always amazed that people think that code is better without punctuation. I
There you go.
never got that one.
Yeah,
I
so
mean-
the challenge, right? So scroll down on this page, but I totally recognize what's going on here. You're in the middle of an expression and you break a line, you have to track it. So the parser for the next line down has to know if he's in the middle of an expression and how many he's actually in the middle of. So he can tell at the next new line whether a semicolon's inferred or not. That's I had to thread a freaking you're in the middle or not.
Exactly. Yeah, it's.
All through.
I mean, the answering Cameron, the thing is that at least in all languages that supported this, I told the IDE to show the semicolons that were inferred. So the thing is, I want to read the semicolons, but I don't want to write them. I think it's the job of the IDE showing me where the semicolon is placed by the compiler. And I think that's a nice compromise. I don't want to write
look at it on the screen. You might as well just put it in the text.
But I want the IDE to show it to me.
Yes,
Then you really need the compiler to tell the IDE. Otherwise, the IDE guy has to write a whole full copy of your parser.
Yes. Well,
yeah, I mean, he has to do that anyway. So
but they don't have to do it so perfectly.
I mean, I'm in the language. If you're doing a language server, I mean, that thing also gets some kind of AST or token stream. And of course, if my compiler supports semicolon inference, it will send the detected semicolons to the front, to the LSP. So I think it's a small problem, not a big one.
There's like some, can't find out, some short text I've seen on the interwebs about how mispronouncing the word read, like in the same sentence, it's used like 8 different ways. There's those things with Cameron's like semicolons in the same line. It's like, no, I can't find it now. Fine. If you read this, it's read or read and read, like read and read and post tense and past tense and color changes. There's a bunch of those, and you know, and a native English speaker just whips it out and it's like, oh yeah, this is how you read it. And of course you parse it in your head, but like, geez, it's a bitch to figure out which one's which. All right, never mind.
So the solution I took to a semicolon inference is actually rather close to the Scala one, which I know the problems with it. And the basic approach is there that you have basically 2 classes of tokens. So you basically say, okay, if this token shows up. All right.
Sorry, it got the German version of what I was looking for in the chat.
Yeah, that's nice.
So perhaps my way was a little, I guess, haram or whatever you call it. But so I don't have semicolons, and I found it fairly straightforward to solve. I did what I had to do at the parser level. I had to basically special case the parsing of return and throw keywords, because if you, in my case, you can just do return without a value, and it implicitly returns nil. Now, you could argue you shouldn't do that, but I do. But then you can end up cases where if you do something like return new line 42, it would think, oh, you're returning 42.
Yeah.
And so what I ended up doing in my parser, it basically says, oh, if the expression that follows the return starts on the same line, we treat it as part of the same thing. And I believe for a while I allowed allowed you to call functions without parentheses, even if you specified arguments. That gets annoying to parse, so that I ripped out.
I've been having this discussion all this week about whether or not you should allow.
No, so what I ended up doing there is if you don't have arguments, you can leave out the parentheses because it's easy enough to parse and disambiguate type check wise.
Okay.
If you do have arguments, you have to give parentheses. I did make the exception that if the only argument is a closure, you can use without parentheses.
Yep.
And if the last argument is a closure, you can put it outside of the parentheses. And that's a bit annoying to parse.
Yeah, okay.
But
It's
it
like,
means you can
I
do
think-
things like, x dot each, give a bunch of arguments, and then outside fn. It reads a little nicer because I
reads a
really
nice-
hate
right,
the
right.
cases
By
where you
way-
end up with like curly
So-
braces and then parentheses.
I
So
think.
did you say that you can do a function call with no arguments without parentheses? So you just say X, like calls X?
Go to the
y-
docs. and
Yeah, so
show-
actually here on the shared screen on line 420, it does max is length. Length is a method in this case. It's a method on
Okay.
self
And
because
so
you can leave
are
self
you
out.
taking a reference to the length, or you're just getting the actual
No,
length?
so my language doesn't let you get references to methods. They get called when you refer to them. So this is something I took from Ruby, basically.
Yeah, and if you want to refer to them, you put them in a lambda, I guess.
You don't. I haven't had a need for it yet, so there's nothing in the language for it. I feel like if you start passing methods around, you should really be using closures because that's essentially what you end up doing.
that's. I mean, that's what I meant. If you want to use length as a method reference, but you don't have method references, you're just putting it
Yeah,
in your
exactly.
closure, right? Yeah. Right.
So I put the AA version of function calls because I was having a conversation this week about it in the doc down the bottom. And mostly the only funny thing is exactly one argument I'll allow following directly without parens. But 0, 1, 2 or more, so 0 in particular requires parens. For me, because it says I have a function call here, and therefore there may be side effects that are non-local, and there may be performance costs above and beyond just what you get out of a variable lug. So it's a flag
So
that
how do you
says
pass a function into a function if you want it to not get called?
I'm sorry, how do I do what now?
If you don't want to call the function, but you want to pass a function into another function, how do you do that? Just leave the parens off?
There's a precedence ordering if you're going to stack functions one after another. So I'll go write the function with no args on it, right? And this is
Well, what's the, it sounds in Yorick's case like he has a particular reason he's doing it, which is if he's copying it from Ruby, it's likely a DSL supporting choice, right?
Yes, for me it's a DSL supporting choice. I can make things that look DSL-like straight out of that.
Yeah,
So,
same. And in my case, also closures are quite common. So I wanted syntax that wasn't as grading as in, let's say JavaScript, where you have like, full parentheses and then you pass a function. Maybe I have OCD, but I really dislike having like ending or like trailing, I guess, where it's like a closing curly brace, closing parentheses. I don't know why, but that's, I hate it.
So you have a zero arg function. I was not doing zero arg function. So there's another zero arg function. Closure is a sole single argument, and I'll do that as a one argument version. And there's your last argument flavored one, which is an interesting choice.
I find it interesting that you're doing one arg function application is, I think, left associative, right?
Yeah, and
Because I mean that's the line you have
left
here.
associated.
The line that you have here, if you say, okay, I'm now putting the parenthesis back in, it basically evaluates in the other direction. Is this intentional that you have to that you can flip it around more easily, or is it just a side effect?
It's not, but I'm liking it. I think it's reasonable. The reason for left to right is so that I could have a function that takes a function, computes something, and returns a result, then takes another function, computes it, and takes another function, computes it, going left to right. I think that reads better than the right to left. With the parens, you have forced and inside out nesting. So you have directly said, fun1 calls fun2, that result is fed into fun0.
See, here's my
Have you-
take, which is an unpopular take, which is DSLs suck. I'm just glad
But
Bjarne. I'm glad
people
Bjarne
love-
never knew about them when he was building C++,
Yes.
because they would have been in there, and it would have combined operator overloading, meta template programming, a C front preparser, and
A few other things.
macros, and just
Right.
at some point, the overload is just too much.
For
As
me,
someone who's programmed Ruby this year, by the way, too much. Sorry, I didn't mean to kill the conversation. I just hate
No,
DSLs.
I was just thinking. I mean, the approach of saying, okay, I handle calls with special syntax. I mean, Scala was kind of innovating in this direction, and I think also Kotlin did afterward, especially with lambda as the last parameter. And I think Swift also does something like this. So it's interesting. It's like some kind of language subculture that has decided that, okay, if my function parameters look in a certain way, I am allowed to use different syntax.
I'm just going to guess I'm not the intended audience for those.
Yeah, probably. Yeah, I mean, I think in Scala the idea was that one was able to write things that looked like control flow operators, but were library methods underneath. Not sure about the motivation for the Kotlin and
so
Swift
this has
case,
got to
I
be
guess.
Derek. What's fun in the last line? Arrow, fun2, fun1, fun0. What's the order of operations there?
That's the equivalent of this line here.
So fun1, oh, I'm sorry,
Fun2 becomes the data and it's chained into fun1,
Oh.
and the result of that is chained into fun0.
okay.
This is a very, very handy and useful syntax that I use everywhere all the time.
Yeah, I've seen this in Elm and I never got it where I liked it. Where the
Yeah,
data,
so
the args on the
this one
left.
has two flavors of it, right? So you have this one,
And isn't there like one
and
with
that goes
tilde?
in as the first argument, and this one where it goes in as the last argument. So you can,
So one is left to
So-
right, and
Yeah.
one is right to left.
they're both exactly the same in this case, but if I have multiple argument functions, so if I do a different variation here, where I say that fun1 actually is a 2-argument
Right,
function,
right.
then
Yeah.
here it goes basically in here, and comma is a white space character, so that would still be valid. And here, if I did X, it would be like that. So, and then Clojure has a really strong convention that everywhere you're doing a operation on a collection, the collection argument is always the last argument. And then everywhere you're doing a transformation of a value, the value is always the first argument. So that convention is everywhere, completely consistent, and it works great. And then these things are useful.
Right. Okay.
So then the way that I would use it is like I'd have some collection, and then I'd say map inc, map something else, and and I could just keep going on.
The collection on
And-
the left, then calls a map.
Yeah. Yeah, exactly. So I can do a map, and then maybe I want to do a filter.
Right,
And then in the end, maybe I want to just sort it. And so I can do like that.
right. Interesting.
Yeah.
I'm kind of sort of doing that with AA, in that array.map puts my collection on the left, and presumably the map over a function returns another collection, which you would then chain with another map call directly.
Yeah,
Yeah.
that's
I'm getting
pushes
close.
for the
So I know that one of your really big concerns is always performance, and
Well, you got
big part of that is cache coherency and whatnot. And so the problem with these types of chained transformations is that you go through the whole thing, and then you go through the whole thing again.
Yeah, it begs
So
for
Clojure-
fusion. Yes.
and
Yes,
begs
and
for
so
some.
Clojure's done a few interesting things over time. And so the original thing that they did was they added well, they made so sequences are lazy, and then they added chunking, so it would actually go through each of these functions, but only on small chunks. So that was a decent improvement. But then later, they added this thing called transducers. I don't know if you've ever seen that, but that basically,
yeah.
So it basically transforms each of these things into a reduce operation, and through the sort of method of composition that they use, you end up doing all the work on each element before you do all the work on the next element. And it's actually a really pretty powerful abstraction. The problem is that it came into Clojure a bit too late, and not everything uses it, and sometimes it's there and sometimes it's not. And so
It's the same in sorry.
Yeah.
So it's a great thing for performance. It speeds things up a lot, especially if you have, I think, cache issues, but you have to kind of intentionally do it.
Yeah, okay.
Yeah, Scala.
All right,
Scala
see
made
ya.
the Scala made the same mistake, where like the strict collections are the default, and lazy collections, I don't like the word lazy, collections are opt-in, and everything is terrible, because 99% of the code should not use the strict collection operations, but people are stuck with it. And
Yeah.
now we had like the second collection rewrite, and it didn't get fixed. So yeah, it probably won't get fixed, and people will just use Java collections because they are faster or something. Who cares?
Yeah. Clojure did reasonably well, I think, because they started out lazy, and they're pretty good. You can do infinite collections and whatnot.
I'm always like to hear that. I start out lazy and infinite collections. The first thing pops in my head is, well, here's a fintech data that's a terabyte in size. Eat it into your Clojure and do some math on it. Oh, look, my laptop can eat it in, a few seconds to a minute, depends on how fast my SSD drive is. And I can process it nice and fast. And Clojure like, nope, choke, out of memory, dead. I'm like, yeah, well, there you go.
Well, it depends. As long as you don't hold on to the head, you will be fine. You will be able to parse the infinite collection, run through the whole thing. If you try and hold on to all the values, you're screwed.
Yep.
I
think, of course, is you gotta hold on to some of them, but maybe, who knows?
I think the whole concept of infinite collection is just wrong and broken, and don't have it, and then you don't have to deal with the issues of conflating like 3 different concerns into one type.
I guess my take would be a little different. It's interesting for a certain subset of things, but there are a lot of problems in the world where I want an obvious, straightforward, efficient solution. And as soon as you said lazy, you weren't going to be obvious or efficient, and I'm just done here. So give me the alternative that lets me say, I have a big ass wad of bits. I'm going to march through them and do some math on them. And I better not do any allocation while I'm doing my math, or statistically speaking, I better do a very small amount of allocation, or I'm going to blow out of memory.
So the nice sort of middle ground with the lazy collection seems to be the chunked lazy. So you have your implementation can be you know, a lazy thing is going to be a linked list of some sort. You know, with a lambda at the end, basically. And then, you know, you can always throw away the part of the linked list that you're done with. And if you do that, then you're good to go forever, basically.
Okay,
And
then the next one I'll say is, yeah, okay, now here comes machine learning, and I'm going to make pass after pass after pass over this. So there better be some very efficient way to hold on to it.
I mean, the trouble with saying, but just throw away the head when we're done is that it's extremely subtle. No compiler will warn you if you go from head will get thrown away to head will be retained. And yeah, I mean, it was the same in Scala with stream. It's just not worth it. I mean, if it's, I'm saying if the collection can give me its size in a reasonably fast way, very, very close to O of 1, it's not going to be a collection. Done. So I'm not going to.
Well, with a lazy collection, you just have to, you know, not be constantly. It's kind of like with a concurrent collection or something. You don't want to be looking at the size all the time. You're really interested. Do you have something now? Is there more?
Yeah, but I think it's a telltale. If you can't even say what size this collection is, it probably shouldn't be a collection. I mean, sure, you can make it work, and size is not the most important operation. But if you're already struggling with size, then yeah, maybe it should just be a function that generates values.
Yeah, if you want to be able to ask, if you want to be able to ask what the size is, you should either be using a synchronized thing or you should be using transactions. Because
I put a conversion operator down below, which does the same thing as the map, except that it is lazy.
Where?
Yeah, he added it to the bottom underneath the last round of.
Yeah, I couldn't find the border, but we can add that later. So you know, I don't typically inline all of these, but this just puts the lambda you're passing into the lambda that you're going to use when you call the index of the thing that would otherwise be a list from a map. So I can't speak to the perfection of this performance, but the JVM doesn't seem to slow down too badly from, you know, sticking the passed in lambda inside of another lambda.
I don't think that's going to matter. If it's a function call as opposed to an interface call, they probably does a decent job. Well, we're getting on, and I have a short AA update.
You want to?
I was hoping to throw out a couple of questions as well, maybe after if we still have time.
Yeah, I can make this short. So basically, I finished out all my test cases and bugs fixings in the overloads and got all my theory side code to pass all tests in all modes with all kinds of extra grievances thrown in, every possible thing passed. So I'm back onto the main code base. Busy re-implementing or rethinking what I'm going to do with the theory side. Henry Milner on the main code base is currently getting whacked to bring in alignment with the theory side. So that's just the progress is. Back to the main code base, working out an implementation on something I want to keep as opposed to something that was intended to be a throwaway. And that's it. And if you're done with your Simon with your screen share, why don't we abort, because I see you're flipping around, which is fine, but there you go. And then, yeah, fire away, Derek.
Okay, so I have a couple of things that I think are smaller. And so see if nodes related stuff.
Yeah.
So I was looking through the papers on, you know, gotchas when you're coming out of SSA. One of them is they call it the swap problem, and then there's another one as well. But basically a couple of ways that you can get screwed where your SSA, your value that you want coming out of SSA has been clobbered in the last iteration and you don't get it.
Yep.
So I wasn't sure how I ended up adding copy nodes into the sea of nodes, and I didn't really like that because then it ended up being too many of them. So
Okay.
then I thought, why don't I make an alias node?
Yeah, back
And
up.
I make an alias node, and which so basically if I say in my code A equals B, then I do an alias node, and then before I leave, I try and decide, is this going into or coming out of a fee? And if it is, then I'm going to keep it and turn it into a copy.
Yeah. No.
Otherwise, I just get rid of the alias node entirely.
Stop now.
Okay.
Register allocator does that.
Thinking I was going wrong.
Yeah. Register allocator does this. All copies disappear all throughout the normal optimization portion. And when you're coming out of SSA and you're doing out instruction layouts, you have the copy problem you're talking about, the clobber problem. And if you just have a register allocator, it's going to come along anyhow, then the register allocator has to deal with this anyhow, and he will. So there's definitely a thing there. So when I come out of SSA, I will put in copies at fees in order to not have to deal with the copy problem, which otherwise you have to do this loopy thing where you look for the cycle and you put the extra temp in. Crap. And then the register allocator gets rid of most of them anyhow, but he has to deal with this problem also because he'll also run into it. So I throw in excessive counts of copies right as I come out of SSA to go to the register allocator. And then the register allocator has all those things pre-split. There's no overlapping problems, but he got way too many copies, but he's really good at getting rid of copies. From a register allocator point of view, that's one of his jobs, is to say, these two things are joined by a copy. If I can assign them the same register, the copy goes away. And that's his job, and you let the register allocator do it.
Okay. You have the advantage of having a better register allocator than me right now. I haven't implemented a very good one yet.
Then let the problem ride. Throw the extra copies in. Your code sucks, and the register allocator needs to get fixed. But don't do it twice. Once where you do a bad hack job with an alias thingy, and then later again with the register allocator. Just do it once.
Yeah.
You suck right now. Know that you need to tackle a register allocator.
Okay. Yeah, that makes sense. So yeah. Okay, so the what was the next thing? Well, I also have a lattice thing. So I was looking at your notes on lattices and how they combine in your AA. You had this sort of big sort of comment there.
Depending on where you're at, the comments are more or less stale, but yeah.
Well, but anyway, it was really just about how lattices can be sort of, you could sort of merge them, multiply them with each other and whatnot.
Yeah, right.
And so I was working through what I need from my types. And one of the things that I need is that I have the somewhat complex system of, I have operations in the array which require a D word value, and then those are of course composed of 4 bytes. So a bunch of operations in the array only need bytes. Some of them take 2 bytes but produce a D word, and so I have this stuff, and I'm thinking this seems like I can deal with this in the lattice. So my lattice started getting a bit more complex on that side. And then it was like, let me just open this up here.
I have this horrific hand-drawn thing. You want the arrow of death, which you can't read, but it says int 32, int 64, int 16, 8, 1, Z, or nil.
Because they're range subsets, right? So
yeah, these are all subsets going down and up, and the twiddle versions and the not nil versions on the inside, plus they top and bottom out at scalar and anti-scalar or anything and nothing. And the whole...
I have a difference. I have a difference here though, because those, you wouldn't say that each byte in an int32 is itself its own useful thing. An int32 is one value, or it may come down to being 1 byte.
Oh, I see. So that's not really, it's not really a lattice. Okay, if you're looking at the parts, if you have a whole and you're breaking out the parts and then you want to put them back together, the whole again,
Yeah.
Do what you do for a struct, which has fields, X, Y, Z, you got a point of fields X, Y, Z. It has parts. You can deal with X, Y, Z as a lattice. You can wrap them back in a struct. The lattice for the struct is a structural recursion over the lattice for the parts. So that's one of those places where lattices can nest like Russian dolls and still be overall be a lattice.
Do you mind if I share my screen? I'll show this
No,
lattice.
it should be available.
All right. Yeah, I can. All right. So basically, why don't I show you what I created? So I created this, and this has all this stuff in it because there's another side of it. And if I show you here, it makes a bit more sense, I think. You know, I have this decomposition part where each piece can be in a specific, you know, decomposed like a struct, like you're saying. Then any value in the array can be from a known location in SRAM. And I think that's really important because I don't have sort of offload memory unless it's a bit expensive to try and store things off. So I want to be able to like just recreate values if I know they're constants for memory. So when I run out of space, say I'm just forgetting about this stuff, which I can rehydrate later.
Yeah. Okay. So you said a couple things that I think you're close, but you're missing some easy games here. If you have a chunk of memory and you want to break it apart into pieces and then reassemble it later in the lattice, it's just the same as a struct. They nest like Russian dolls. There's no game there. It's just the same lattice. If you're loading things out of SRAM and putting them back, or loading them and then reconstituting them from constants, that's the register allocator's job, who can be told, this thing I can make in code as a constant as opposed to loading it from memory. So when I register allocate in your static SRAM, and I have a value which can go either way, I'll load it from here or I'll make it in the code. And that I claim that's the register allocator stuff. Like if he wants to spill, hey, I'm out of space, I need to spill this thing. I freed up from my storage. I need it again. Oh, down here, he either pulls it from storage or he builds it from a constant. And he knows he can do it either way.
This is as true for the legal system as it is for any other system. You never know. Maybe
somebody's watching a video
for an old school for his bribe. Or
Jim,
maybe
I'm muting you.
Okay, so anyhow, the
sorry, Jim.
yeah, so I agree. I'm pretty sure that this is the register allocator and not the legal system that requires this to be done. And,
yes.
But I think I need the lattice to be able to keep track of the fact that it's from a specific value and which SRAM value it is. I think that's lattice world.
So I'm claiming that's memory edges, what I would call loads and store memory edges, followed by the register allocator dealt with it. So when I went to stack frames during register allocation, I made the stack frames be registers. So I would take your static RAM, break it up into individual chunks, call them all registers that are fungible goods. Now the register allocator makes those chunks live or dead, and he either remakes the value from whole cloth as a constant, or he leaves it in the register, which is a chunk of SRAM, and then he loads it and stores it in and out. But that's just another register, and it becomes a register allocator job.
Right, so it's a use-def edge.
And there's a use-def edge, yes.
Okay, that makes sense. And actually, this brings me to the other sea of nodes question. I'm just going to get rid of the lattice here. Oh, yeah. Actually, let me stick to the lattice here first for a second. I think that this decomposition where I basically say that I have this sort of high level lattice, which, you know, it has this, then here, and then down to here, and it doesn't actually have this sub thing in. That can be a second lattice. I can have a kind of stack of lattices. And so if I'm in here, then I can say when I'm in this range, then I can also look at this. When I'm in this range, I can also look at this.
So I would claim that it's very useful to write the tool that verifies that your Hesse diagram you're showing us is also a lattice.
Yeah. And I will. I was looking at your version of that in AA, and it seems like it's a reasonable thing to port over.
You're totally welcome to cut and paste that sucker.
Yeah. So yeah, okay. So it seems like this is a good, a decent way of looking at things, because it seems like it makes me these nice simple lattices that look like this versus giant lattices that look like this. Where everything's sort of
Yep. Yeah.
Okay. So that's
I
lattice.
conceptually think of much of what I do with the lattices as either nested like Russian dolls or side by side is the obvious other choice you end up with.
Yeah. Okay. So the other thing that I'm thinking about, so when I have a state, you have a state of some specific hardware register, and then something does something, and then now that's in a new state. So I have an arrow from the old state to the thing that did something, and now that represents the new state of that thing.
Yeah.
But I may have operations that are reading from that value, and they need the old value. So is it just the job of the scheduling to make sure that those nodes end up in between the state objects that?
So as part of doing the scheduling algorithm, I will throw in anti-dependencies exactly for this case. They're not in during the core optimizer, but when time comes to flatten, I'll throw in anti-dependencies so that when I do the graph walk for laying things out into whatever, it's in fact just a simple graph walk. It's literally for all nodes, all edges, blah, 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 do a stupid graph walk thing. And you get the layout that's correct and reasonable. But to do that, I need the anti-dependence edges. So I add anti-depth edges right at the end. I mean,
so you stick in. So I have register F, and I'm doing something that needs it in its current state. Then I change F.
Yeah.
Eventually, before I schedule, I take that thing that I did, and I put a anti-edge to the new F.
Yeah, it's another def use or use def. I treat them the same as all my edges. It's just another edge. It has no semantic meaning for the consumer. It's just an ordering operation. So
I guess I just need I can add another edge to the thing that changed F that says it depends on the other thing, which it doesn't really depend on.
Right. You add an edge that he doesn't really depend on, but he's there to prevent him from going, and you add in the correct direction so that all the edges flow, how you want to draw
same
them,
direction.
top to bottom. Yeah. Right.
Okay. And so do you do that as well when you're doing things like loop unrolling, because you need to create a schedule then too, right?
No. Loop unrolling cheats. I tried very hard to keep it fast with too much engineering. So now the engineering gets complicated. The anti-deps for the scheduler are really a stupid thing that I just do a dependency check as I'm walking forward, and I look at the uses of a particular def, and the load uses have to enter the next def, and blah, blah, you add the anti-deps edges and you're done. It's a straightforward walk, and then you walk again for scheduling. For the loop guy, I had an incremental dominator tree, as well as discovering things that I thought should have been below or above. And I did do a bulk, not any control flow graph, but here's all the guys that are in the loop without any order between them and no basic blocks. I just walked you this way, and took the intersection. You're in the loop. Okay, now I'm going to loop unrolling. I'm going to clone you guys stupidly. Blunk. Now there are no order in between them, and they have edges going helter-skelter between them and outside in all directions. So I just clone chunk. Okay, now I remap all the edges in the clone to get them to point to themselves if they're within themselves, and outside if they're outside. And that all worked right up until I had multiple exits that were shared, and now I need fees because the two loops each take a parallel exit to the same, deopt because I range checked code or whatever the hell it had to happen. And that screwed with, and I used the incremental dominator tree, but it screwed with my incremental dominator tree, but I needed it as well. And the incremental dominator tree told me that somewhere these two exit paths merge way down here, and this is where the fee goes. And it got, like I said, it got complicated fast. but I didn't build the basic blocks for unrolling. I simply said you were in or out. And I had a list of everyone who was in or out. And then I cloned the list and I remapped edges. And that was good up until I needed extra feed functions for the multiple exits. For everywhere one loop had an exit besides the fall off the bottom, the other loop had a similar exit. Those two exit paths eventually needed a fee in the right place.
Right. And so by doing that, you're guaranteeing that everything that you're cloning actually needs to be cloned, because anything that's loop invariant sort of pushed out of that little
It wasn't in my list. If it was a loop invariant, it wasn't in my you're in the list. So this was, walk the graph top to bottom, walk it bottom to top. And if I found you, you were in, or if I didn't, whatever, I took the intersection. It wasn't walk the whole loop. I actually could walk the boundaries. But I had to do a walk there twice in one each way and intersect. And the intersection was reasonably smart. I mean, he just quit walking if he knew you were already dead the other way and whatever. So he cut himself out. In practice, everything that you got deffed by a loop and exited, and everything that got used by a loop and entered in some path got touched once, but things that were not touching the loop at all never got touched.
Right. And then is it hard to, I haven't really looked into this part of it, but is it hard to sort of figure out how to rewire fees and whatnot?
For the loop ops, it got complicated, and I can step you through it. The biggest part was I used an incremental dominator tree to help me find those spots. Otherwise, you're probably better off coming at least partially out of SSA and rebuilding. That will be a lot more execution time for your compiler. It's a big piece of work. But
I'm right now I'm okay with I'm prefer to do something where I can land it faster, and even if the compiler performance suffers, because I'm not JITing, I'm doing ahead of time, and so far I'm able to compile a large program in under 1 second, so I'm still in good time.
Okay, fine. Then I would claim, go easy cheesy is go out of SSA, clone all the things, and then when you come back into SSA, you'll discover the right fees. Also, again, the one trick I got
coming out of SSA means just schedule it like normal. And don't bother doing.
You have to have proper basic blocks. You have to have proper names for things. So you have to solve the come out of SSA loopy problem for crushing names. You don't have to be super clever about it. So you can dump in extra copies everywhere. And then those copies will be in your face when you go back into SSA. So the thing that I got out of this, though, is that after I did the cloning hack, I was already in SSA. Immediately, much of the cloned code was usefully optimized. All the new clone shit usually was duplicates of the old clone shit, and or had other redundant tests and redundant this and that. There's a lot of optimizations that the people just ate right up. So it was much quicker to spin unroll a loop, make a loop clone, stitch them together, optimize or shrink it back down to the size it was, and clone it again, and iterate a few times because you need to unroll it 4 or 16 times or something to get a reasonable.
Right. So then you do clones and powers of 2 rather than
clones and powers of 2. Yes. So my unrolling was all done in powers of 2.
I had another idea, and I was curious what you think of this, because normally you have to have up to n-1, or you have to have like another loop afterwards or something to deal with the, I cloned 16 times, now I need 15 more afterwards.
Right. Okay, so I take a loop, I make a pre and a post clone. The pre and the post clone run the iterations that the range check analysis says I can't verify in the normal. So they leave the range checks in. Also, the pre-loop runs all the loop invariant tests like null pointer checks that are going to happen at least once, but only if the loop runs once. There's a 0 trip count around the whole thing. So you take the loop, you add a 0 trip count, you add the pre and the post. You optimize pre and the post, and you don't let them unroll or disappear if their trip counts are 0. You analyze the core body, throw the range checks out, adjust the trip counts for the range checks. Fine. Then you take the core body and you clone it once. If it's too small, you clone it. And you stitch it back together, and then you do the math on the trip count and say, I need an odd iteration or not, add it on. So I put it on the post loop. And so the post loop trip count math got complicated by the odd iteration. And then lather, rinse, repeat. Oh, I'm sorry. How do you guys pronounce the 3-letter word for a internet image? You know, spell GIF. How do you guys pronounce it? This is
GIF.
Yeah, I pronounce it like the peanut butter.
I mean, it's the G
GIF.
from graphics, so clearly it's GIF.
I said GIF.
So the guy who designed it says it's pronounced like the peanut butter, but most people pronounce it with a hard G. I pronounce it with a soft G only when I want my kids to get mad at me. And by the way, 100% success rate.
I've got a kid who's a real programmer. I'll have to pull that joke on him. Okay. Fine.
Kids apparently hate it being called Jeff.
I'm sorry. My wife wanted the peanut butter for lunch, so you know that's my clue that I need to wind it down. And I had the joke sitting here on my desk the whole 2 hours. What were you saying, Derek, before I interrupted?
I think we were kind of had it figured out. So we were just talking about the sort of remaining trips. So did I understand correctly that you basically you do inlining powers of 2, but you might throw in 1 or 2 extras when you're expanding, so you end up without needing a big
when I do the power of 2 clone, I have 2 copies. In between the 2 copies, there's an exit test between the first and the second, because the unrolled piece had an exit test there. I get rid of the exit test, so I got a double-sized block, no exit test. But now maybe I ran an extra iteration because I'm counting powers of 2. You know, it's not I++ anymore; it's I+ equals 2. So where does that? How do you track the extra iteration? So I take the in max for the max trip count, and I say, you know, and off the low order bit. If it's set, I need an extra iteration in the follow loop. And I lather, rinse, repeat that as I unroll, and the optimizer just folds all that shit up. So at the bottom, it says, take the low 4, you know, if I've unrolled by 16, he just says, take your trip count mod, you know, 15 or and off the 15 bits and add it to whatever I had to do elsewhere. And you get some cheesy thing. And then you have a few iterations at the end. So I'm only doing it by 16 if I know your trip count's going to be big.
Yeah. So the idea that I had is to basically have jumps into the center of the loop body. So like, and maybe this is a bad idea.
This is a bad idea.
But okay. Because then I was thinking, well, maybe it would prevent
a bad idea.
all my, it might prevent any optimizations from actually happening.
It does. This is exactly why the on-stack replacement code from Hotspot has worse performance than the normal entry. So here's the usual loop. I'm writing micro benchmark. Int main has string arg of n, the large number, for I equals 1 to n, do something stupid, n. Okay, so after a little while, I decide to compile main. If I compile main, and the next time main is called, and you know, it'll run the optimized code. Okay, main's never called again. Right, okay, so now I have a loop spinning. So now I go say, okay, here's the set of bytecodes that are hot. I need to make a function entry for the middle of main in the middle of this loop. And what it is you always get the wrong point and you can't do any good optimization. And that code is always of lower quality than the code where you called main directly. So if you want to do this, you get the good code number, you say main says for I equals 1 to 10, he calls function x. And x says for I equals 1 to bajillion, do a bajillion stupid things. And then after a few iterations, I'll compile main in inline x, and that won't work. So then I'll compile x. Next time main calls x, you'll get the good code. So you'll get this tiered speed up where you're interpreting everybody. Your main is running interpreted, and you're calling x. And I guess that's you'll OSR into a main with x inline, and then you'll get a main calling x where x has got the better loop. So you get a tiered performance speed up as
you
I
have to wait
figure
to
out
finish the first x
call. The next time
through all that pain.
The next time you're done with the first x, you will call the hot good x.
Yeah.
So that's a symptom of trying to JIT code that's in the middle of a loop. So the other one is that if I have a lot of trifinalies, you get a lot of irreducible loops. And those unroll like bitches and have, jumps in the middle. And so I'll take an irreducible loop and I'll do the partial peel where I basically rotate it like it's a clock and peel off a leading edge until I hit a common single entry point, then optimize. So the loop ops do a lot of work to clean up your shitty loops before he actually goes to town. Including, getting rid of irreducible and shared common headers. I have a bunch of back edges, but it turns out that you wrote it nested this way, but the hot one is nested that way. I'll look at those and stare at the profiles, and I'll resort the loops so they are nested the way the profile says they are, and then I'll get rid of the shared headers and get a basic block for each header, so at least the register allocator has a chance to move spill code into the headers of the less hot loops for the hot ones, but go on profiles, and there's a lot of loop cleanups going on in there.
Yeah, that's the loop landing pad stuff.
Yeah.
Interesting.
But that's a name I haven't heard in a while. So you've been reading the source code.
Yeah. I went through the add,
headers,
multiply, and subtract nodes and implemented all of the optimizations. It took me just one afternoon.
Yeah. So fucking the core optimizer bits are like so easy. It's like fucking hell. What? Why are we not all doing this all the time? Fine.
Yeah. So now I'm. So I was pretty happy, but now I've got some stuff where I end up with a bunch of dead code after that, or like nodes that have gotten disconnected.
Yeah. And
so I was writing code to clean them up, and as I was writing it, I was thinking, I think I'm doing this wrong because I think this should be done with the type stuff first.
Oh, interesting.
And decide whether it's live or dead, and then clean up the dead stuff. Because right now I'm sort of like gradually unraveling stuff and being like, oh, this is dead, that's dead. I'm just deleting the nodes.
Yes.
And then the algo is getting more and more complicated.
Oh, I see. So for me, I just when you say dead, for me, dead means no uses. So as
so there's no uses, but then there's also like somehow, say I've got a binary operation and I managed to figure out that I can delete one of the things that's going into it. So therefore it still has one use, but it's actually, I could just delete it.
No, as soon as you have
I know that somehow the other thing's going to go dead anyway.
Like if you got an and of a mask that is redundant, and you fold yourself up into I'm an identity on the other guy, then the guy who was the and mask went dead. He ends up with no uses.
Yeah.
Okay. As soon as you got no uses, you should delete them, and recursively you'll have no uses, and repeat until you're done. And that's a common thing. Yeah. So in the C2 code base, I do that a little more locally, but it happens globally. It shows up on the work list. In the AA, I just threw them all on the work list. And the work list, first thing it does is, you got no uses, you're dead, delete you. And the things that now their use count dropped to 0, go back on the work list. And then the work list just spins the dead code off, and I don't have any other places. The single point of failure is getting rid of dead.
Isn't there an exception though? You could have no uses, but if you're pinned to a region, then you're still. You
pin to a region in my world means you have an input edge from a node who's pinned, like a divide by 0 has a control edge to a region that guards his vertical travel. He can't go above the test for 0. Okay. Yeah. If he has no uses, he's dead. I delete him, and his uses go away, including his edge to the control. He had no uses. He's a dead divide. You get rid of him.
Okay.
He's not pinned in any classical sense. He's just got a use def edge.
Right. Yeah, and I guess anything that's state changes should end up tied to the state at the end of the program.
Yes, they should all thread memory through. Yes. So deletes. Stores that go dead remap the memory edges as you would expect, but the store could go dead.
Yeah.
In which case the store has no use, no memory use, no uses at all. And then it's a dead node, no uses. It rolls right up.
Yeah.
So always the rule is, if you're actually dead, you have no uses. That's the definition of dead. And if you were mutating state like a store, and you decide that state mutation was junk, so you can get rid of the store, you remap the memory edge around the store. The only use of the store would have been the memory edge. you got no uses, you dead.
Right. So I think what you're telling me is that I need to finish the state model node stuff before I work on any more optimization stuff.
Yeah. Yeah. And then all
Because
those
right now I don't have an end or a start program state, and those state
okay.
nodes are a little bit floating.
No, tie
And they
them to
don't-
the ends, and then say if they got no use, then the rule there is no uses is dead is a totally simple way to deal with dead code, and then it just disappears. And it
Yeah,
disappears eagerly and quick in the peephole. You never have to watch it.
Yeah, and so I've got another interesting thing. I don't know if you want. I can talk about this stuff next time. I know we're getting a bit long on the time, but
what other people want
I've
to
got
do here? People want to break, or you guys are interested? A lot of shrugs going around.
I'm interested.
Well, one more, and then I'll break it anyhow.
Okay. So basically, I realized that because I've got this sort of two separate worlds going on, I've got the code that's happening in the risk controller and code that's happening on my array, I end up with the need for multiple returns a fair bit. So I just decided to make multiple returns part of everything. And so that turned out to be an interesting thing to model, because I didn't want to do it. I still haven't added any kind of vector or tuple classes to anything.
Mm-hmm.
So I have structs, but I didn't want to, but I have those things created only at program boot is the only time I can create a struct. And after that, you can only use structs. You can change them, but you can't make new ones. Basically I thought, well, I think I can still do multi-return, especially I just decided to make the return node be basically it acts like a select, except it's a select where it can have many inputs. It's still tied to its place where it returned from, but it have many inputs, all the state nodes, all the and then however many returns that I have, and they're indexed, and then the state nodes are named.
Okay, so wait, when you say you have multi-returns, you mean you're returning multiple values, or you have multiple returns in a function?
Multiple values also have multiple returns from a function.
Okay,
but any one return has multiple values.
Okay, so for me, what I do is
I
fold all the returns to.
Go ahead.
All right, I fold all the returns together to one return with just the fees. So you end up with one return for the optimizer's point of view. Later on in the code gen and things happen in the, that then I might have tail code duplication going on, but that during the optimizer, make it one return with fees to merge all the returns, including all the different values they all return. I auto return multiple values. I do return control, I got here at all, the state of memory, which would be all of your state, and a normal value, which could be a tuple. As soon as you want to say my state of memory includes scratchpad memory versus this memory versus that, that's fine. Just fatten out all your returns and return them in parallel.
Just lots of returns and
lots of
being
parts
in
of the
there.
return.
And so the way that I modeled it so far is that I have this return node at every point, and then at the end of the function, I've got one overarching returns node, which just has one tie to each of the return nodes.
That's your fee.
And so that's my one. And so basically it ends up with being a multi-compose and a multi-select. And then the call site is, I have another node there that I call call return. And that just points to, it may also have an actual compose select if there's multiple functions that I could call.
Okay. Yeah, okay. I did things a little differently, but maybe it's roughly similar.
Yeah, and so basically, out of the call return, I sprout out a bunch of projections for all the things that can be returned. So there's sort of this chain of nodes which represent this bundled collection of values. Of stuff, and then finally, after you get to the end of the chain, the call return node opens it up into all the projections.
That's roughly what I'm doing. So I have a call epilogues, I have call return, same thing, fine. He takes when I do call graph analysis, he ends up pointing to Well, he has a special pointer to the call, so the call and the call return are linked directly. But then the call return, or the call epilogue, has pointers to every known return he might point to, and these are all their own functions. They all have multiple returns who end up pointing to their all calls if they're, the usual problem for a C program or anybody's is you get this zigzag of calls and returns, but this guy gets multiple returns, and you can call from here, and this guy calls here, but he also calls there, who then gets from here. Get this, that's a normal effect you get out of this. Anybody who does a call graph. So you're doing a call graph on top of a regular basic block of a function. As soon as you do a call graph, you have to deal with zigzag. Sounds like you're doing it pretty much the same way I'm doing it.
It seems like it's okay, and it seems like I can do things like, oh, I didn't use this return value, and I kill it all the way through the function return and kill it all in the whole function.
Yeah.
Or
it
kills through the arguments and kills into the killing. That's the best part of this whole thing.
and if you do it right, it's almost always just the dead code eliminator. For the projection guy, I do a special thing where the call epilogue has his projections of things. So if this projection goes dead, I have to peek through the call epilogue one more layer and say, you, Mr. Return, I'm not using this. So I'll nuke that to a null, that edge. And then those things all disappear. And I do it for everybody, and find it out.
Yeah. So I have to understand how to sort of thread myself through this compressed path where everything's bundled together. But
this is where I get what it amounts to. Progress for nearest neighbor gets complicated. Your original description of what you're doing with fees let you do the progress in exactly one step. So the neighbor was literally a neighbor in the graph. As soon as you have this kind of neighbor where you've bundled things, fed them through a thin pipe, and then expanded them, your neighbor is now more complicated. It has to, and that will force you to look at places where you go further afield than one step. And so you have to think about how that works to go find a neighbor.
Yeah, well, I was already doing that with the alias nodes, and I ended up changing my graph match. You know, I have the graph matcher as a sort of abstraction thing where I actually put a little pattern in. And so when I generate the pattern to match against, I just walk through the aliases.
Yeah.
And so I'm going to I think I'll get rid of that stuff. But anyway, the same idea, I think, can work to go through projections.
Yeah. Yep. Sounds reasonable.
Yeah. Anyway, that was a bit more just of an update piece, and I'm pretty happy with how that's coming out. But
cool. All right, gentlemen, I think I'm going to call it. And until we meet again. Actually, Friday. Yeah, fine. So next week is Thanksgiving in the US, but Friday is not. So I should be on here Friday.
One question, Cliff.
Yeah.
What social network are you going to be announcing next compiler meetings on?
Jesus, what the hell? So far, Twitter hasn't failed me as an announcement protocol, but geez, what the hell to do with Moon Unit there? I don't know. I'm just not the social networking guy. I don't want to deal with learning another social network, and I'll have to run two for a while. If I want to pivot, right, I'll have to do something there. So I still find cool shit on Twitter for guys, So I have dodged. The other one is going back to Facebook, which I dodged forever for. I just couldn't handle the spamminess of Facebook.
Yeah, I've joined Mastodon like half a decade ago, and just recently I started using it again. It seems to be getting most of the people in my social network, so maybe it's gonna be fine.
Maybe.
Yeah. It's pretty nice having like a 3-letter names.
I hope
available.
that he loses like, $20 or $40 billion and decides that he's incompetent to run Twitter, and he hands it off to a decent CEO and walks away. But if he's going to push, Republican nonsense at us, I'm just going to have to, vote with my feet. Like, oh shit, dude.
There may not be that many people left running Twitter also.
Yeah, it's too late now. It's already on the, it's just, the wheels are spinning, but it's all momentum, and it'll just run downhill from here.
I think
I heard bulk firing.
75 to 80%.
Jeez. Well, that's cut your daily expenses.
How much did you hear what, like, he had that ultimatum?
Turned off half the microservices.
Sorry?
Yeah, I heard that, and then promptly people said, and look, my newsfeed hasn't changed in a week.
That was the problem with Twitter, is they had too many servers running code.
Yes. That code is doing something though. Okay, fine.
And I know how many as well. It's a lot. It's more
I
than
read
think.
something that they're trying to cut $1 billion off of their hosting expenses a year.
So they do
That seems
most
like
of
a lot
their
of
own hosting, but
Which
they
is
did
tricky
have
because it was
I-
about 800 million a year.
I
they
mean,
did
if
have a
they're
move
not,
at some point in the history to go to public cloud, but that worked out poorly.
I mean, they can
I don't
just
think the way you
declare
save
that.
money is by going to the cloud.
Exactly.
You only save money if you're small enough that you don't need a whole server.
Yeah.
I mean, they can declare
assuming
that they
they
are
do.
not.
Sorry. What were you saying, Simon?
You stopped halfway in the middle.
I mean, they can declare just saying that they are not saving or retaining media files older than 2 years or something, and most people will probably not notice, but storage, I guess that makes up most of the storage, not the text, but
Well, there's going to be the power bill.
the smartphone,
They're trying to cut
smartphone
it.
stuff.
Bill, what were you
Aren't they on a
saying?
microservices architecture? I think they are. That's
Yes,
where
they are.
that alone would probably cost you at least $1 billion.
Yeah. That's right. That's not the most efficient way to run these things. Yeah.
Bill, what were you saying?
Yeah, I was just curious if anybody heard, like, there was a button you had to push if you're going to stay at Twitter as an employee. Did anyone hear how many people, like what percentage of employees clicked?
People are talking something that they are now down 75% or something.
Wow.
That was
Really?
At
before
least,
yesterday, though. I heard
I
it
mean,
was close to 90.
sorry? Yeah.
It was getting
What do you
close
do
to
when the
90.
person who runs the service that tracks whether the button was pushed leaves?
No, they're already gone.
Huh.
Yeah,
You know,
I
any
think
of these
they.
like mass cutoffs, the good people always can go and land on their feet. And so you not only cut it out 90%, you kept the 10% or the worst 10%.
Yeah, I think that the latest what I
disaster.
heard is that the remaining employees got an email with well, I'm here until midnight. Why don't you fly to San Francisco for the meeting? And kind of expecting that every engineer there has access to their private plane or something. It was nice.
I'll get right on that. Here's my reimbursement. I actually have to ask for my reimbursement first. Here, you hand me a free use company credit card, and I'll get right on that.
Yeah, but I mean, at least looking at the Scala portion of Twitter, where I still track people, I mean, not many are left, I guess. So
Yeah.
all the Scala tooling infrastructure build stuff doesn't look that good, I guess.
Twitter's all on Scala?
Yeah,
Not
bunch
all,
of it.
but
Yeah, but I knew there was a lot of it. Yeah.
Okay.
Yeah. Again, not the most efficient, but
No.
rewrite
Yeah,
everything
Twitter
from
has
scratch.
over
ain't gonna
10 million
happen.
lines of Scala in their code base.
Yeah, it's not going to happen overnight.
I think
mean,
the bad news for Twitter is bad news for Scala, actually.
Oh, that's true.
Yeah, because if you're running a 1 million line Scala code base, you better have tooling experts that keep your IDE running and your compiler fast. Otherwise, you
Yeah,
have no
right. That's got to be one of the larger Scala support bases floating around.
Yeah, Twitter had a whole JVM team that was making sure that as they made changes to Scala, that it still ran efficiently on the OpenJDK.
As of a few days ago, they still had most of that group.
At least, okay. So maybe some selectivity on who got fired.
I'm guessing that none of them pushed the button.
Oh, I'm sure. Yes. And nothing like be a trained monkey or lose your job. I'll be like, see ya. I do not need to be treated like shit. So see you later. Bye.
Yeah, the downside seems to be, though, that he didn't actually follow through on that. So now he knows everyone who's not willing to push the button, but he's not giving them a 3-month vacation. Kind of sneaky.
Isn't that standard anyway? I'm not sure. I mean,
no, US, it's usually,
I'm
if you
trying.
had vacation stacked up, you're owed it. But otherwise, it's at will employment. Either
Alright.
side can say, see you later, bye.
I mean, even if in California,
Oh, yeah.
I mean, they are not living in the complete Middle Ages, so
No.
they might have.
It's at will. You can leave, and if you fire me, then I am entitled to benefits that are modest for like low income blue collar workers that the state makes the person fired pay. So instead, you want the person to rage quit, then you don't have to pay them the minimum.
Right.
But these engineers in San Francisco are well above that, so they're making enough money that it didn't matter. The unemployment kind of question to matter. So at that point, it's just at will. I choose to leave, you choose to fire me. Either way, you're done. And then vacation's basically pending money you owed me. It's like a partial paycheck that you owed me. You haven't paid yet, so you have to pay that up.
All right.
Yeah, and anyway, even if you
But it
manage
has
to
unlimited
engage someone
vacation.
so
They don't
much
have to
that-
pay it out.
I'm
if
sorry?
you manage to, if you intentionally enrage someone so much that they quit, then the rule is that's just constructive dismissal anyway. So you don't
is
really
that
get away with
enforceable by any reasonable law?
Probably in California.
Well, I don't know. In Canada, that's how it is. But you know, if you basically mess with someone, just hoping to get rid of them.
What's the burden of proof to show that you've messed with them before they can call I've been fired by rage quitting or whatever? Fired.
Yeah, I'm not sure. I've never had to deal with it.
In Canada,
It's
they
just
just count up the
our
number of
lawyers who have
sorries
this
from
about
each side.
firing people.
They do
Sorry,
rock,
Derek,
paper, scissors.
I was saying in Canada, they just count which side says sorry more.
Oh, sorry, yes.
Yeah,
Sorry.
that's right.
No, it's Canada. It's sorry.
Sorry. Oh,
Sorry.
nuances are beyond me.
Sorry.
I don't speak English barely, and certainly not Canadian.
Eh?
It's a weird language. Not many people understand it.
This is where your opportunity to say, "Oh, sorry." It's a weird language. Sorry.
So what Aaron was
It's a weird
saying
language.
earlier is that a lot of these companies have switched to unlimited vacation, and the reason is because then they get out of paying you for the vacation when they fire you.
Oh, that's an interesting plan. It's not a bad answer. Honestly,
So Oracle,
if
Oracle
I need a
changed
break
it.
and I don't care and I
Oracle-
don't have to count vacation, I'll take my break and we're both happier. But if I'm doing shit
Oracle
job and
changed their
slacking,
policy.
fire me.
Oracle changed their policy like that, Aaron, just after they fired me for some reason.
It's pretty well
How much
known, though. I
vacation did you
think
owe you?
so. When we were hiring, when we were scaling up our startup, we were just, we did a 4-week vacation thing. We just told people like,
Yeah.
we're not those shady people who do the unlimited vacation, because everyone knows that nobody takes it, and then you don't get paid out on it if you leave. So it's like, it's a benefit. You have a finite but decent amount of vacation.
Yeah.
Yeah, over here, HR will start haunting you if you're not taking your vacation, because it's
Right.
considered
Yeah,
a
we do that.
liability, because it's basically money they are owing you but haven't paid you yet, and they have to pay it in some way. And apart from that, if people fall apart, if they are having no vacation, I mean, that's not helping anyone anyway.
Yeah, I had the problem that I didn't want to take vacation, so I stacked up way too much of it, and I got hassled by a lot. And eventually, when I left Sun, they paid out a big chunk. And then I was in startups where it was a different game. You're a co-founder, founder startup. No vacation doesn't. There ain't no vacation. Different story. All right, I'm getting my vacation now. All right, now I want to eat. I'm getting really hungry here, guys. We have to be done with like Twitter. Matt's quick poke at Twitter was like, geez, there's a sore spot there. You popped a sore spot. We're all like going, yeah, geez, what the hell is going on there? And some sympathy for Twitter employees. All right, that's it. Till we meet again next week. Bye-bye.
Bye.